Awesome. Okay, so this is the Dynamo subtomogram processing workshop. We will learn, hopefully today and tomorrow, to pick tomograms, to align subvolumes from tomograms, to average those, and to do classification. And luckily, we're here today with our esteemed guest, Mr. Daniel Castano-Diez. I don't know if you recognize this where that picture was taken, but I got a hold of this. He wrote Dynamo. Dynamo is the software we'll be learning. It's GPU accelerated, which back 5-6 years ago when he started writing it was a big deal, and it's still a big deal because it's very fast and useful software. And Daniel wrote 99.9% of the code or so, but it was also driven heavily by Misha Kujashev, who is now a PI, a group leader at MPI in Frankfurt. So you can thank them for Dynamo. They've done great work. Switch my slides. All right, so a quick overview. How Dynamo, how do I actually make this full screen? I have no idea. Is there a full screen? F11 maybe? Yeah. No. That's okay, we'll leave it like that. All right, so if you attended the talk that Daniel just gave, you'll understand the basic workflow of the Dynamo, but I'm going to go over it for you anyway here. So Dynamo, in general, you've collected dozens of tomograms with Serial EM or Legion, whatever your favorite tilt series collection software, and you've gone and you've lined them. After you've done that, then you're ready to actually start extracting whatever heterogeneous type particles or membrane proteins, whatever's in your actual sample. You might have lamella, something inside of a cell, so you might have tons of different types of things where some of them are related to others, possibly by a different conformational change. And you want to actually go through your tomograms and extract all of the like things and keep them together inside of each dozens of tomograms in a single project. Dynamo can do this for you. We have what is called a catalog manager, which was added a few years ago by Daniel in order to help various users who are having this exact same problem as he described in his seminar. So what we do is we essentially we have a database called the catalog, which you simply assign all your tomograms to that catalog. You give some metadata that you have for those tomograms, and it keeps track of everything for you. Then you can go into each individual tomogram one by one and do manual or semi-automated picking. So there are different things called models inside of Dynamo. So when you're actually looking at a tomogram in 2D projection or 2D slices, projections, or 3D views, you're able to tell Dynamo, I'd like to pick this type of particle. You may have just individual particles, or where you click is where you're going to extract, or you may have particles on membranes. So if you have a membrane protein and doesn't form does or doesn't form a nice lattice on your membrane, then you're able to go into Dynamo and model that membrane, draw a mesh on it, identify locations on that mesh in a uniform where you want to extract particles. If you have, for instance, a pseudo crystalline or a pseudo repeat on your membrane of a protein, you may want to overpick because you can't be sure that where exactly your proteins are. And then during subtomogram alignment, you can do effectively in silico purification of that protein. So that's what we call models, is the types of particles that you want to extract, be it from filaments, straight down the filaments, or around filaments. You might have helical filaments. As you saw in Daniel's presentation today, you might have filaments with randomly oriented and bound proteins. Dynamo is able to help you extract all of those different types and more, and we're going to go over the main models tomorrow, actually. So you have multiple tomograms and a catalog that binds them all together, and then you're able just to say, I'd like to extract all of this type of model from my tomograms into a folder, a data folder that is nicely formatted for Dynamo. Dynamo, as you learned during the seminar, was initially developed for after you have your little subvolumes, and then from there on you go through alignment, through classification, potentially multi-reference alignment, and various different types of masks you can apply until you choose your final structure, whatever that may be. Right. So the catalog manager will export a nice data folder along with tables and pretty much set up your entire alignment project for you. There's additional information that we need to actually go over today, and this is the first talk is generally the one that the users don't like, because we're going to go over nitty-gritty metadata junk that is not really fun, but that's okay. You need it. Take your medicine, right? So Dynamo, when you go through an alignment project, you have various different types of computing devices that you can use, and this is part of the subvolume averaging workflow. We will today be using a GPU workstation that I have set up actually under my desk. It has 4 GPUs on it, and Dynamo is able to use all of those or any number of those GPUs. It's also able to use multiple CPUs at once, and I think in the future it's going to actually be able to use multiple CPUs and GPUs at the same time. Maybe it's already implemented. I'm not completely sure. It's already implemented. Awesome. I don't know actually how to do that, so Daniel can potentially tell you later this afternoon actually. And Dynamo is formatted to be able to do alignments on clusters given proper configuration, either clusters of CPUs or GPUs. And it has a gigantic visualization suite, which you'll see here on out. So let's go into Dynamo basics. Let me actually try to find. Now, okay, we're going to make this window a little smaller. I have over here my other workstation, and let's do this so that you can all follow along. So is on one of your handouts you have an SSH, the ability to SSH into a machine here. And so SSH -y, Tomo Workshop at 192.168.4.100, and the password, I forgot to write it on this paper, I actually put it on that wall over there. It's the same as the password from yesterday, NYSBC Workshop. So go ahead and log into there, and you will by default have Dynamo already installed. If you'd like to install Dynamo locally, we can go ahead and do that. There's probably a lot of interest in doing so it's probably a good exercise to go ahead and do. So let's, well, Dynamo is a large, do I actually have Dynamo tarred somewhere? It's a great question.
Alex, sorry, where's the password?
Right on the wall over there, NYSBC Workshop. Yeah, sorry.
Lowercase.
Lowercase, one word. Yep. Let's see. What I'm going to do for you as a quick and dirty method is quickly download Dynamo for you. This will be a good time for you to go to the Dynamo website and actually learn what's on that website. So go to dynamo-em.org, which is also printed on your paper. Here we have basically a wiki-based website that Daniel has created, and he keeps updating usually whenever users ask him questions that he hasn't answered in a wiki-type method. He'll answer them for you on the wiki and send you a response. So whenever you go and ask Daniel questions, give him quite a detailed overview of your problem or a description of what you want to do in Dynamo, and he'll kindly, hopefully, if you're lucky, kindly respond with a nice wiki response, complete description. He's very good with that for me, honestly. So on the main Dynamo website, you have your citations and all of that, of course, and you have links on the left. There's a download link. I'm going to go quickly download Dynamo. You can do this on your own too. If you're connected to the Ethernet, it should download rather quickly. So this is a Google Drive link. You'll have to go through this little portal, click download, and save your file. This is a tar file, so Dynamo You can untar it inside of a Mac or inside of Linux. If you're running Windows, which I don't know, is anybody running Windows today? But you have access to your Linux machine, right? And so you're doing everything through that.
Yeah, I've got
You should. I don't know if Windows has been supported in a while. Does Windows actually work? Only if you have MATLAB, I believe, right?
If you have MATLAB and some C compiler installed in your system,
Yeah.
there is a chance that it works.
There's a chance that
use my
it's.
computer, but I use my workstation.
Yeah. Yeah.
Taken apart now, so.
The Windows version is, I'd say, maybe untested as of currently, at least. Possibly older versions work. All right, so even though it has 2.8 gigs, we can download it quite fast. It's nicely hosted on Google's website. At least my workstation is able to download fast. We're connected up. Everybody's here connected to the same machine at once. That's okay. So if you have a Mac, you should be able just to untar that. So I'm over here on on my Linux workstation. I just downloaded it to my download folder. We're going to go in here, a bunch of stuff, but I also have Dynamo. What I'm going to do is actually install this in that Tomo workshop directory for you all. Since you all have the same access to the same account on this computer, let's not all install on that one computer. But if you have your own computer, go ahead and follow along. So we're going to move this Dynamo tar file to this other user's directory. Secret passwords.
No, because that's a totally different problem.
Okay.
That's so many software coding.
Alright, so here I'm going to make a temporary directory. By default in this workstation we have in the bin directory Dynamo is already installed. We're just going to install it for presentation purposes here so you understand actually how to install it yourself. So we're going to make another directory, temp bin. We're going to move our Dynamo file that we just downloaded, this 2 gig tar file, over to temp bin. And essentially all you need to do is tar xfv this tar file. I believe that's the correct. Go ahead, go. I think my connection is being lost. Maybe you're all downloading the file right now. Okay, there it goes. All right, so.
Yeah, it seems to be unusable.
Oh, is the Wi-Fi going dead?
It kicked me off and I can't even load the feed.
Perhaps we're overloading the networks
We are
right now.
So we should partner up.
Maybe partner up, and if your Wi-Fi is dying, then use the Ethernet over here. We do have long cables, so they will extend past people, but that's a little messy. Or partner up. So that's up to you guys. 2 people at one machine should work fine.
No, but I mean,
Is your internet
if
dying?
they're just 3 people that need Ethernet.
Yeah. Yeah, there's various Ethernet cables. Okay.
You can also review on your monitor.
Yeah.
Otherwise, you'll overload your workstation.
Yeah, exactly. I don't know if you'll overload the workstation.
Because I'm on yours. And I don't want to repeat what you're doing.
No, don't repeat on my workstation.
I'm working off of my machine.
Perfect. Excellent. Good.
I downloaded it yesterday. So it has the same, sudo c kudo demos.
Sorry?
Just checking it has all the.
Oh, yeah. Perfect.
What? If it's too slow, then we can partner up.
Oh, yeah, of course.
No, but right now it's okay.
Yeah.
If everyone gets that.
Make
Yeah,
sure
sure.
everybody's partnered up properly over here.
No problem.
So if you want, we can share it here. Okay. If in case there's more cables. On your chair, pull up a chair.
Okay, so while your stuff is downloading, I'll just explain why Dynamo is such a large file. So, as Daniel pointed out during the workshop, he has included the MATLAB execution files, and he's essentially compiled all of Dynamo in MATLAB so that it effectively has MATLAB underneath it, and it's all freely distributed. And so we don't need to have MATLAB. If you do have MATLAB, you can run Dynamo on top of MATLAB, and it works potentially a little bit better in various places. So once you untard your Dynamo installation file, then you have multiple different shell scripts and actually one MATLAB script. If you're in MATLAB, then all you need to do is run this script right here. So if I was in MATLAB right now, I would do run Dynamo activate and hit enter, and then it would place Dynamo in the path and make sure it's properly executable. I don't have MATLAB installed on the machine. We do have it installed in the cluster, but it's an old version of MATLAB. I think it's 2012, so it's not optimal. So the standalone version is what we're going to use during the workshop here. There's also setups for MPI and various cluster setups. The one we need to actually source is this one right here, Dynamo Activate Linux Shipped MCR. So this is the longest name here. And so this is already sourced in your bash RC on this workstation, but if you have just downloaded it on your computer here, then you need to source that in your bash RC, which means you need to be in bash. If you're not in bash, you can type env-i bash. This will give you a fresh bash environment. And then if my connection doesn't die, maybe we all shouldn't download at once. Maybe the video isn't even going across the door and the audio and everything. Who knows? If you are downloading, I guess I'd ask you to stop, if that's okay. Okay, so now I'm in a new bash shell. It still has my Dynamo source. Oh well. So all you need to do is source, let's see, we had temp bin, Dynamo, activate, Linux, MCR. So that's how you would source Dynamo. I've already had it sourced here, so if you're on your machine, that's how you source it. Source that big long Dynamo activate file right there, MCR. So this is on your workstation, yeah. So that should work as long as you're in bash, and it did work, so you're completely good. Now what you can do, either if you're on your own machine or if you're on this Tomo workshop login on your sheet, to run Dynamo, type Dynamo lowercase x. And this will bring up, yeah, so Dynamo lowercase x, that's what I typed right there. This will bring up a Dynamo console, and this is the current home base for Dynamo. Okay, so make sure everybody's gotten to that part. I am going to zoom back out, make this window a little bit smaller for you. There we go. All right. And we're going to go over some Dynamo basics. So we've already obtained Dynamo. Now we're going to learn how to get help from within Dynamo. So if you don't have a Daniel or a Dynamo expert near you, then you need to understand how to access all of the different features that Dynamo has in its arsenal. And so Dynamo has an extensive help functionality which can guide you through all of its functions. All right, this used to be the old Dynamo main menu. Right now, the current version has this menu. So disregard this particular image. This was the home base. So within Dynamo, you can get to the wiki page, which is the website, just by typing in dwiki. So this console right here is effectively, it's some random error, but it still opens up fine. This is this is effectively a Dynamo command line tool. Am I actually in here? Okay, great. So now you're at the website. We're all connecting up to this computer, and it might be breaking it. Who knows?
For Mac users, I really advise to go to my page and download the software, because all the visualization with the standalone is going to be difficult if we are exporting from the Linux workstation. to our Mac, we're going to suffer all the time. So that
Yes.
I would really advise that we take 5 minutes.
That's a good
download
idea. Let's make sure everybody gets their own copy right now.
Do we need OpenSD for it?
No, I mean, it will, if it doesn't find OpenMP, it will
What is it?
complain, but
Another
but it
instance
will
of Firefox
use
is running
other
this close.
protocol for parallelization.
It's because I'm actually running
Okay.
this
So
right
that's-
now. So if I
that's,
close
you
mine, then
download
you should be able to do it.
Well,
So that
Oh,
is
you're
running
on
your
yours.
machine.
Oh, yeah.
Well, whenever Firefox opens.
It is okay. Yeah.
It's
not sure whether
complaining
the
that it has.
error is coming from that machine or this machine.
No, this looks like it was coming from your Firefox.
I know, but
Yeah, that is,
is it from Pucky or from my laptop?
No.
Uh, Probably that computer over there. You probably have a Firefox
the
window
wiki?
open on that computer.
I'll just watch.
You can watch that part. That's fine. Yeah. Do you have it downloaded and installed? How fast is it going? Oh, yeah. Yeah. So who does have it downloaded and installed?
I didn't do it on my Windows.
Ah.
It's not gonna work, yeah.
Yeah,
It broke.
plus my workstation is down now.
Where did you?
It's okay. I can follow along.
No worries. All right. So from within a.
Can it looks like? No, the thing is that if you downloaded the Linux version, not the Mac version. Otherwise, you would have a using Gillian. Can you go one? When, for Mac users, when you download the Dynamo package in the wiki, bear in mind there are two different packages, one for Linux and another for Mac. Both of them work in MATLAB in any platform, but for standalone, the Mac needs the Mac precompiled package.
It won't work on these. It's
Yeah, so
Windows.
we're not gonna, because
This is
Windows,
those as Windows?
we're
Yeah,
Windows,
both
so
are
we're not
Windows.
gonna.
No, the standalone will not
That's
work.
fine.
So
Yeah,
that
so
you
we
will
follow
have to-
along.
Yeah.
Yeah,
Yeah.
we're not gonna try and.
Sorry.
No, that's
Okay.
fine.
Philip, did it work for you?
Oh,
This is a local installation in your local machine?
yes.
Okay, perfect. That's okay, good.
I didn't want to launch the wiki page. I would have to kill all my tabs.
What?
I didn't execute that because I would have to kill all of my tabs.
Ah, yeah. Yeah, the thing is that the standalone, all the web commands go to the to your system browsers. When you're working in MATLAB, it produces a MATLAB internet browser, but it's not available in the standalone version.
Will I be able to use it now, or will it need to come from?
Yeah, I mean, if you do it again, it will create a new browser. I mean, or
No,
you-
it won't, because it'll complain about exiting the old browser. Just to have a lot of tabs open. And
Oh,
it's all
okay.
kind of,
then,
it's going to complain that I need to quit Firefox.
Yeah, we don't with
yeah,
PC, so.
yeah, it's connected to the system
Oh,
browser.
cool.
You will
We can
have to
follow you
close
guys along.
it.
That's fine.
Excellent.
It's working very
Yeah,
fine.
we're doing good.
I think most people are on the same page. You're able to run it somewhere.
So it has
Well,
It's more complicated.
Will I be able to do
because
the other
you know what
commands,
is
or
the
just,
syntax of the
I mean,
cluster.
I don't care about doing the
But the
wiki,
thing
but
that-
I want
Yeah,
to
you
share
would
it
try
with
another
other
command,
people.
like
there is a
try
web
DCP.
page in every cluster in the world where the admins
Dynamo
tell you that
create project, I believe it
those
is,
are the
or
headers
Dynamo
Okay.
that
something
you
project. Yeah, so
that
just X that out. We're
yeah,
not to
basically
that part yet. I just wanted to see if it worked. Totally works. Awesome. Thank you.
Is that like CryoSpark or something? Needs a browser.
Not. Oh, okay. Yeah, that's right. Doesn't need a browser. Is it working okay, Ash, or are you still waiting for it?
No, that has an error when I.
Okay.
Okay. All right. So most of us are up, and Daniel's helping those who aren't. Daniel's helping those who aren't completely up yet, which is excellent. All right, so we can get to the wiki page, and from that wiki page, like I said, there's various help documentation there that Daniel has put up for various people. Ask him questions if you don't see something there, if you don't see something in the actual help documentation inside of Dynamo. So here we can type dwiki table to say, hey, is there a wiki for what a table is? And you're essentially just searching the website for table, and yes, indeed, tables are a basic metadata system in Dynamo. It explains it completely for you, and it's in complete wiki format. Yes, so I typed dwiki table. So it's essentially going to the website and searching for table, and if there's an entry that matches that, it'll bring it up for you.
And essentially, if you're moving through and there's something you're not sure of, just dwiki and whatever that word is. it can
That's
show you.
one approach, unless you're looking for something really specific and esoteric than that. But if it's a clearly common thing inside a Dynamo, then probably will work.
I have that open.
Yeah, it's a good way to go around.
Oh, okay. Yeah.
All right. I like that you're all interactive right now. It makes me happy that you're following, so this is good. You're excited to work on this, so wonderful. You can also type dhelp, and this will bring up as we can see in the PDF here, and I'm going to go through part of this right now, help documentation from within Dynamo. So let me maximize this screen. We'll get back into this Linux Dynamo. And yeah, there is a little bit of lag. That's okay. So we can go through, and so here are all the standalone commands that you can use from the command line. Okay? So Dynamo is a lot like, your eMan and your iMod, those pieces of software. They have a whole suite of different commands that do various different operations on volumes, on various different types of data. And Dynamo has the same, or a separate suite of its own. And these functions are actually what Dynamo is completely built upon. But you, in general, work straight from the GUIs or the command line if you are brave enough, if you wish. So if we, not available in precompiled version of Dynamo, of course. So we can look at a different command category. This means if I have, let's say, a project, what types of commands can I work, or what types of commands can I work with here? And then you pull down the next menu and you have all of your different types of project commands. You can, we'll get into these in the GUI version. You can check your project, make sure you can copy your project. You can develop an even, odd, gold standard project from your existing project, etc. All right. Let me get back to my Windows. Yay. So there's also inside of Dynamo, as a third source of help documentation, an entire set of PDF tutorials. And so these exist in your Dynamo folders. It's basically your Dynamo/doc folder is where all of your PDFs exist. And honestly, this is where I myself the vast majority of Dynamo before I was an expert. So you can go and right-click on any, this is a very common thing in Dynamo, any piece of text that you can point at and interact with. You can also right-click. When you right-click something in Dynamo that is operable by Dynamo, you will be given a selection of different things you can do to open or observe that file. So you can just do an ls on it. You can copy it to a clipboard, but you can also open it. So this, hopefully this does work within the Dynamo standalone. Told it probably does, but perhaps it doesn't.
Try the other PDF reader.
Probably the events, is that? So if we right click, maybe events works. Yay, events works. All right, might be machine dependent here. So if you're ever stuck on a particular workflow within Dynamo, say you want to understand command line classification, then you would go to dhelp, you'd go list your PDFs, and you'd go through the Dynamo classification tutorial on your own. These tutorials were made, a lot of them were made about, interesting, we cover previous documents, sure, why not. These tutorials were made roughly 4 years ago, at least most of them, so they might be behind in the visuals, so they might not completely agree with the interface that is currently the Dynamo interface. But yes, I highly recommend using these PDFs whenever you're stuck. They go through, as you can see, in very clear detail, how to use different parts of Dynamo. All right. There's also, you can look at the Fourier sampling. So we're working with tomograms, which means you are tilted around at least one axis. It might be the x-axis, the y-axis, even the z-axis potentially. You can have, there were previous versions of, or previous implementations of tilting schemes. Some of them included dual tilts. Some of them included making a cone, so it more or less like RCT, but in a cone. And you can also define custom missing wedges and tilt and Z, beam around, or tilt and Y, beam around Y, tilt and Z, beam around Y, tilt and X. Those are rarely used. All right. Yes, so we went over this. You can go look at your PDFs. We also have complete description of what tables are. So tables, much like in Rely On, where you have an individual text file that keeps track of all the orientations and various properties of each particle. In Dynamo, these are called table files. They end in extensions .tbl, and there are a couple dozen or a few dozen columns in each table file that you should understand at least the basics of. So let's quickly go over this here. My screen is a little bit lagged. That's okay. The first entry in a table file is the tag number. This is the particle number. So you'll have each row being different particles. So it'll go 1, 2, 3, 4 all the way down to the bottom. You can skip particle tags in a table file. It means you can go through and individually remove those if you like, if you have a reason to. The second column is whether or not this particular particle was aligned, usually for a given iteration. Third, was it average for a given iteration? Then 4, 5, and 6 are the shifts that a given particle has undergone during a particular iterative alignment or alignment iteration. And then these 3 Euler angles define the rotations that the particular particle has undergone at a given iteration. And Dynamo uses the ZXZ convention. So if we have, let me get an object here. This is our particle. And this is, let's say this is the box of our particle. So this will be the Z direction. Whenever you open up any particle inside a Dynamo, it's usually depicted such that Z is facing you. So this TD rot is a rotation about Z, so it's this rotation right here. And then tilt is a rotation about X, which is, I believe in your orientation, pointing this way, so it's tilt in this direction. And then the last orientation, NA rot, which is column 9 here, is a tilt along the new Z, which is this direction, I believe. And so that gives, that's the convention that Dynamo uses for Euler angle identification. Different software uses potentially different conventions, so be aware of that. Column.
You use ZXZ? I'm just curious. Is there any reason you use the ZXZ? As opposed to ZYZ, which is.
No, I mean that once you decide that something set is more or less the same. I mean, the reason was that I wanted to interact all the time with AV3, and AV3 used ZXC. That's all.
Oh, I see. I mean, Spider and a lot of the MRC, they use ZYZ.
Yeah.
Kind of. in E-Man we picked ZXZ, but that turned out to be kind of a pain in the neck for that reason.
Why did you pick it? It was
Because the book we knew best was Goldstein. Used ZXZ. To be honest.
That's a very legitimate reason. Cool. The 10th column here will be the cross correlation. This will be for a given iteration, the correlation of that particle with the given template. If there's more than one template, I believe it gives you the correlation for the best template, I think.
no, it's never.
Oh.
You never have more than one template in a table. When you're doing multi-reference alignment,
Yeah.
you have one table for each template.
That's correct. Yes, you're exactly right. CC2, you can give different options for different. You can add an additional layer of correlation in your alignment. CPU, which CPU is described on or aligned on. F-type, so this is Fourier type. This describes the Fourier sampling of that given. It's determined by the Fourier sampling of the tomogram from which that particle was extracted. If you're doing just regular IMOD reconstruction, I believe that is generally given with the tilt axis along Y. So here you would use option 1, and if you want to actually understand all of them, you would click over here on this help for the Fourier sampling convention. Then 14, 15, 16, and 17 describe the angular range where your missing wedge actually exists in the given orientation. So you have Y or you have X. And if you choose 1, it'll read 14 and 15. If you choose 2, which is tilt around X, it'll read 16 and 17. Then we have some free parameters. Tomogram number, so this is where if you extract particles using a catalog, then it'll keep track of which tomogram your particles came from. This is very useful because you can go back once you've aligned all of your particles from a bunch of different tomograms and done classification, perhaps done sub-boxing alignment and classification. You can go back, and there is a script of functionality inside of Dynamo where you're able to place each of those independent subunits that you've gone through and you've aligned back into the original tomograms, so you can observe those aligned averages and classified averages in situ in your tomograms, which is wonderful for both presentation and analytical purposes. Reg. Oh yeah. Okay. 21 is more or less an internal number for identifying regions inside of tomograms. Then we have class number, arbitrary labels, followed by XYZ of the original volume. So this is where your particle was extracted from the original tomogram, and this information is kept constant, or it's kept up to date when you go in and do subboxing, which allows Dynamo scripts then to replace the subbox subvolumes back into the tomogram. It's very useful functionality.
Origin is 0.
Origin is 0. So
0,
like
0, 0.
Where is the origin?
The first pixel.
That's a great question.
So the corner of the pixel of the first pixel is 0, 0, 0. So the middle of the pixel is 1.5, 0.5.
But is the origin in the corner? Is the origin in the corner?
In the corner, not in the pixel, but in the.
But is it in the middle of the image if you have a lot of pixels?
Yeah, of the corner pixel. The origin is the corner of the corner pixel.
Yeah, it's down
Yeah,
here.
exactly.
Yeah, not in the center of the paper. Okay, and then we have D-shift, D-axis, DNA rotate. So these are differences between iterations of these values for a given particle. So you can watch to see if there's how much residual there is, and this may be an indicator of if you have if your alignment is actually asymptoting geometrically or in alignment space. Then we have a few additional parameters here that are not so useful, at least for generic users. Original tag, subboxing. So when you do subboxing, 31 is used. Number of added particles, it's not too useful in my opinion. Alright, and then angstrom per pixel is defined here. Dynamo by default works completely with just regular pixels and Fourier pixels. If you wish to define angstrom per your pixel size, then you may. And also you can keep track of your defocus for any given particle or tomogram. And 41, 42 followed by additional columns are used for eigencoefficients when you do classification, or for additional free parameters that you're allowed to play with on your own if you wish to save notes, for instance, for a given project or particles. All right. Boop. Let's go back to the PDFs. Come on. There we go. Okay. Great. Okay, so we can pull up individual documentation for individual functions inside of Dynamo. So here we have DFFC. This, as you might expect, is whenever you see D in front of a function call, that is a shortcut for, or a shorthand for Dynamo. So this is Dynamo FSC. And if we go look at the doc or the help file for that, we can do that directly from the Dynamo command line or command console. So what's it? Doc DFSC. If I can type. The doc command cannot be used in compiled applications. Hey Daniel.
It doesn't work in the standalone apparently.
No, just type DFSC.
Just type DFSC.
Or is that just the GUI interface?
No, this will be the GUI interface. Yeah. Yeah. All right. Does it work in the Dynamo executed without the X? This is something I have not tested with this version.
Is the wiki FSC.
Yeah.
So that it will bring you to the wiki page of the FSC, and maybe the help is in the wiki. Maybe.
Okay, we can try that. Try this first. If you run Dynamo without the little X, then it will bring up the old version of the Dynamo command line. So let's see. I feel like it should work here.
Oh, yeah.
It works.
Wow. She kind of.
Oh, you found a way to get it to work?
She opened the interface.
Oh, okay. I also found a way to get it to work without the interface.
Okay.
So if you run Dynamo in the newest version of Dynamo without the X at the end, then you're given what is the old Dynamo command line. From this old Dynamo command line, you can enter in many different commands that the current Dynamo command console does not fully accept. So here we have doc DFSC, and now we can look at the entire documentation of the FSC function. If it would please update. Oh, okay. It just doesn't let me move the. That's fine. Yeah, Jillian has also found a way to do it. Okay. So, in general, for this function in particular, how to read this is if you want to use DFSC to calculate the Fourier shell correlation between the two volumes, then you would do DFSC down in the command window, followed by volume A, which may be a .em, .mrc, .spi, your standard file format files, and then followed by the second volume. And then you can give it a large number of options. You could tell it, I'd like to include symmetry in this calculation. I'd like to include a mask where you would impose an explicit mask from the disk. You can, of course, give the pixel size and Fourier masks, etc. And each documentation is, at least the main functionalities inside of Dynamo are very well documented. So this is a great place to go to learn about various Dynamo functions, which may not be available from the wiki or from the PDFs. All right, wonderful. There's also help, which may actually print the exact same thing, right? Yes, so this prints to standard out instead of to a GUI window. So that's essentially the difference between help and doc, I believe.
Does it work in the
Oh yeah, yeah, it
in the
definitely works.
standalone?
In the standalone without the command console. So in the command line version of standalone. Works. All right. We have d-apropos, and actually I had to Google what apropos meant when I first read what is Daniel saying when I used to go teach workshops. I'm sorry. Yeah. Oh, it is. I didn't know that, actually. I had to Google the English meaning of it. So it essentially is what types of things does Dynamo let me do with a various different with a particular functionality. So if you type just d-apropos by itself, and you could do this on your own machines here, you're given different families of commands within Dynamo. So as I said, Dynamo has, and we can actually, let's actually go open up a new tab, go into, since we're doing a more or less comprehensive workshop, let's get a little dirty. Oh, I have my Dynamo installed in a different location. Don't copy where I'm going right now. So if you go to your Dynamo folder, there is a subfolder called MATLAB. There's an additional subfolder called source. Inside this source folder, so here I'm in Dynamo/MATLAB/source. Here you will find, I believe it was maybe 400, 500 scripts. Okay, 1,400 scripts that Daniel has kindly written for everybody over the past 6 years. And a lot of these are not, or I wouldn't say a lot, there's a number of these that aren't actually implemented in either the GUI version of Dynamo, and actually some of them don't have documentation. So there's some beta functionality within this folder. If you ever have a desire to, if you're ever wondering if you could do a particular functionality inside Dynamo, then you can, if all else fails, go to this folder or email Daniel himself. Right, so back to d-apropos. I have too many windows open here. All right, so d-apropos gives you information on all the families of commands inside of Dynamo. So if we type d-apropos, type that right, yeah, main, then we can see some of the main functionalities in Dynamo. We have an align GUI, we have a manual alignment GUI, we have an averaging GUI, etc. We can go back. Let's look at, no, let's not do plugins, that'd be too complicated. Subboxing. So we have a few different commands that are dedicated to subboxing, where you can extract or replace back subboxes from your subvolumes. All right, so what we've gone over so far is how you help yourself use Dynamo. And as you can see, Dynamo is an extensive piece of software, not only for doing just subvolume processing, but it has plenty of additional functionality for filters and placing back your subvolumes into tomograms, etc. So we're going to go into basic formats in Dynamo. We've already touched on the tables, and we're going to also talk about how your data needs to be formatted so that Dynamo is happy, and then we're going to jump into Dynamo alignment projects. This is the core of Dynamo. So let's begin, and you can follow along by making a tutorial. So we're going to type in this, d-tutorial, and then test, and then -p, and my test, -p, p-test.
The command line?
You can type this in, I believe, either in the command console or the command line version of Dynamo, either Dynamo X or Dynamo without any X. So here I'll shrink this window over here. And she can process everything in her head in real time.
No, I just watch it, and then there's so many installations.
Okay, so from here, the tutorial, and let's follow the PDF guide. Also, if you want access to this PDF, you can on one of your handouts that I gave out.
And URL.
Yes, I gave a tiny URL, so you can go to that, and we are following currently the Dynamo basic PDF tutorial, which you'll find partway down the page. All right, actually execute this. Did it work over here? Yes, okay, wonderful. So I had this running in a different tab. I can move my window over here. Yeah, okay. So we made a test project, and what it did, if we can scroll up really quick, yeah. It just instantly made a project, wonderful. And then from here, we can go to Tools, and we can just say, find projects in this folder after you make a test project. And you can see here the project we made, and I see a few of you are following along with me. There's Yangzi. I made one called P-Test, so I'm going to. That's fine. Oh, did it complain after you did it?
No, I mean, I'm just like, I assume that everyone's gonna do P-Test.
Yeah, that's you're you're ahead of me on that. All right, so just to go over what we just done, we typed in dtutorial mytest -p-test. It executed. It made a new project, and then we went to Tools. We went to Find Projects in this folder, and we're clicking on that project, and we're going to click OK. And
How
sorry.
do you get that window with the found projects?
You pressed OK. I know. Daniel writes comedic code occasionally, as you can see down here.
Because you need Dynamo, that means the Dynamo X for this, right? If you don't have Dynamo X, then you just start with the command line.
Oh, wait a minute.
I would just, I mean, you can do yes.
Oh, actually, you need to go to this Open Dynamo Wizard for subdiagram projects. And then go to Load, pick projects in this directory. And as you can see, we have another set of projects that somebody has made. And from here,
I can load the same project again.
you go to Load, pick projects from the directory.
So
Yeah.
when I type that into my project, it
Wonderful.
won't recreate. It will
Yes,
just
exactly.
enter the
No,
same.
you
Perfect.
already created the test already created.
So I do the D project. Okay.
Yep.
D project.
All right. So this made a tutorial project, which we can now. Actually, okay. So you can stay where you're at, and I will give you an additional set of tutorials. If we type in dtutorial by itself without additional commands, then we get this tutorial GUI. In this tutorial GUI, you can make a fake set of particles that are picked from a fake tomogram, essentially. It's all synthetic data. You can give it multiple particles from multiple classes. Here, I'm not going to make another project. I'm showing you the individual features here. And so then we can have, we can simulate a dual tilt or a single tilt. We can give it
And then once I in, just
tilt angular range. This is your missing wedge. And also we can simulate noise and give each of the particles a random shift, essentially. So we've already done that with our single command right here. And then we went and we went to DCP, Tools, Open Dynamo Wizard. From inside that DCP, we went to Load, pick projects from this directory, and we loaded our project. That's where we're at right now. I'm going to make sure you're all on the same page, so I'm going to walk around for a minute, make sure I haven't lost all of you. Oh, you can. So do you have? Did you go to load?
Just there.
Test here, so it loaded
So
everything.
did you?
This is on my machine.
No,
Yeah.
it didn't do anything.
Yeah, oh,
But you're in the right folder, that's all. I think that's what it means.
oh, I see.
Yeah, so it's not doing anything. But yeah, we're in the right folder.
Maybe in the standard you cannot click on finish,
Okay.
and then we have to do something different.
Okay.
Go to tools.
It's a little, slow, now it'll open up.
And you
I don't think
inside
it's,
of here you ran
slow.
Switch
I think it's simply not working.
Yeah, it's low for me too.
So let's
Okay.
first
We are
do
going to
Dynamo.
You're using the
space.
Dynamo X terminal?
Mm-hmm.
Yep.
Okay, Dynamo.
Can you change this?
The whole thing crashed.
Okay, so from this
The
we need to
standard
switch
normally
Dynamo.
used to be
So I don't know where you have it.
locally or used forwarding mails
Okay.
and replacement. What you do is,
Clicking the command now.
oh yes. What you normally
You should go to
do is,
dot slash dot
start on the project,
dot slash.
and then I
So
open
dot
it
dot
with
is
to enter the
downloading
The
capital.
other thing, probably we can just open the GUI directly without any project, and then we load the project.
And then
This
slash
project is
Dynamo. You can use the, oh, not
But-
Dynamo X, so it's the directory, so you need to source that,
No, I think he's Alex is taking a small detour explaining how to use the tutorial for more advanced. Felix doesn't look convinced. Ah, no, it's working. Okay.
Have you did this work in the past?
Oh, it's not opening my GUI. Why
I can use the.
So you need that degree something.
Okay, so
Like nothing like degree.
Is
You
everybody
type
else
the
okay?
projects first to see what's in here, but you know your name is like
Yeah.
over here.
Okay,
all
cool.
right here.
Double check this side of the room.
Yeah.
What?
Why is there nothing there?
I don't know.
You should override it.
Exactly. Okay, now.
Let's just press enter.
Excellent.
Ah.
All right, so we're pretty much all on the same page right now. Awesome, good work.
Anyway, it'll come with this.
All right, so inside of, so now let's actually go through and look at the directory structure
Maybe close
of
it.
this
Redo.
Dynamo tutorial
Should be in the dynamic.
project. So if we go to our regular Dynamo window, we can see, and where am I? Where did I actually run this one? Ah,
So you will type, you have typing and
Ah,
then you
good
type
point.
it on this one is the other one.
okay, if we go to our Dynamo console window, not sure if LS works here. It certainly does. Excellent. We can see that we have a bunch of different projects that everybody has made. Perfect. And what you can do is you can type D summary. This will give you. It's this window right here. This will give you a summary of all of the projects in the current directory, or at least, yes. So it says I found 8 projects. So we're all doing a lot of work in this computer. Excellent. And we found 4 cross-correlation matrix. This is a classification project that is made by default when you do dtutorial function.
And when it's in blue, it means that it's doing something.
All right.
Instead of not to click and passing
So
numbers.
let's go into, I'm actually going to go to a different terminal window and log in as Terminal Workshop again. All right, if we go into our ptest directory, let's look at the directory and file structure of this project. Yep. Okay, so here we have, I'm getting a little lost because there's so many projects. Not a problem. Yep. All right, so if you go to the My Test directory, this is where all of the actual files are stored for the tutorial
What's the path?
dataset.
It's p-test, my test.
No, it's My Test, not P-Test. So go up a directory and go to My Tests. All right. So here we have a course aligned table. So this is a table that the tutorial data set made based on the known orientations of the particles that it synthetically derived. Here we have an initial table. This will be a essentially a blank table. So let's go ahead and look at that. Indeed, if you remember and I do remember the columns of the table format, we have our particle in the first, followed by is it aligned, or will it be aligned? Yes. Has it been averaged? No. And then dx, dy, dz, and then Euler angle 1, 2, and 3. So this is a bare table. These don't have pre-oriented particles in it. And here we're using, in this column, the Fourier sampling is in the y direction from negative 60 degrees to 60 degrees. And we have these fake initial positions, x, y, and z in the original tomogram from tomogram 1. Otherwise, everything else is blank. If we go look at the course aligned table, here we have a roughly aligned set of particles, and as you can see, they've been averaged, at least synthetically, and we have x, y, z along with your Euler angle orientations. And then there's a real table here where the actual where their actual orientations are. Let's go into the data folder. So the data folder, do an LL. Data files in, or at least subvolumes in Dynamo, need to be named particle underscore followed by 5 or 6 numbers, though it may accept more than 6 numbers. I'm not 100% sure. Does it accept more than 6 these days? Particle numbers?
Yeah, you can put
as many as you want?
Yeah.
All right, so if you have 1 billion particles, Dynamo will take them. Well, if you're Florian Schur from John Briggs, you have at least 1 million particles in your project.
Well, the problem is that if you have 1 billion particles, or the problem you have more than 100,000
Yeah.
particles, in many file systems,
Exactly.
they don't like to have so many files in the same folder.
Yes.
So you have to use a different particle storage schema, the data schema. But we can, I mean, that's for more advanced for you.
I did have that problem back at Florida State when there was a point in time where I ran into that problem.
So you have that problem.
I did. We were running a Lustre file system, and I was limited to like 20,000 files, which is useless. All right, so this number designation corresponds directly with the particle tag number inside of the table files. All right. Let's go back to the tutorial PDF. Come on, window. There we go. All right, Dynamo likes EM files, but it also accepts MRC and Spider files and potentially a few different types of formats. I recommend just sticking with the EM files. You'll never have an issue in general. All right, so we've gone over the particle naming extension, also accepts .vol particles. And as we just went over and discussed, you can use this data functionality, potentially contact Daniel for information on if you have over 1 million particles or 100,000 particles. All right, there is very informative and useful functionality for looking inside of data structures inside of projects. So if you use the if you go to either the console or the command line version and type in dinfo, and if we're in the right directory, I believe we are, my tests, absolutely over here, we have information on our test project. If you go and type in, as in the tutorial PDF, my test/data, and you'll get information on your actual data particles. Let's go ahead and make this bigger for you. All right. So yes, our data is located in here. We have 8 particles. They have tags numbered with these. They are all 2 megabytes. So this is a good way to make sure all of your files are actually there and the same size, and they're all with side length 64. So this is the box size, and this is the cubic box size, and they all exist. That's great. Okay. Always hit that button. Wrong one. Let's go over here. Okay. We've already gone through the apropos data. We can use, yes, so this is, if you have hundreds of thousands of particles and you're having issues potentially with your project not running, you want to make sure that your data is actually there and it is actually consistent across all of the data. You can type Dynamo data tests followed by
Check.
yeah, check. You're right. Thank you. Followed by the data folder. And couldn't create. I'm having Java issues. Let's get out of the Dynamo console on this terminal, so we can kill it. Excellent. Go into the regular Dynamo command line, and that should probably work. We can also do this from the GUI.
We should kill him.
You don't need to. I was having an issue with Java bringing up Windows. You may, yeah. Okay, so once you type in either to the Dynamo command line, or if you find it in the GUI, which we can show you that also, and if the screen refreshes completely, maybe it won't, you can see that all of your files have been detected. We have a file at particle number 4, 14, 20, 24, etc. They all are with flat padding, okay. And they are all the same size, and none of them have not a number value, which is good, because if you run into NAN numbers when doing any type of operations on your particles, then Dynamo will probably crash at that point. Let's see if we can actually kill that. Good. All right. Where did the rest of my... Here we are. Excellent. Okay. So we have in our tutorial data set, we can quickly view all of our particles if we wish. You're going to type D slices and then your data folder minus JZ. So you're going to look in the Z direction, and J is, I believe, for projecting, and asterisk, so you're going to project all your particles in the Z direction, is how to read that. D slices data folder minus JZ asterisk.
I got this same Java.
Oh, you got a Java error too? So where did you get that? From that window? Okay, so if you close that, and then oh, that's interesting. I just exited my command. Did I type it in wrong? I don't believe so. So it's not working for you either? We can access it in a completely different way. So that's not an issue. So if we try it here, perhaps it'll work. If it doesn't, we can...
Where's
Yeah,
the
so we
Dynamo
keep getting...
executable?
it's in the MATLAB bin folder, but you should never have to go there. As long as you sourced your Dynamo Activate Linux Shipped MCR properly, then it should be in your path.
Okay, you're in the folder.
Alright, since our dslices isn't working, what we're going to do is we're going to open this project in the GUI, and so we can actually view it in the GUI. So you can either type in DCP, or you can go to the tools, and then go to DCP inside of the tools. And once this refreshes my screen, and we go to load, pick projects from this directory, I'm going to open up this project again. Dynamo has loaded it, and now we're in the GUI, and we can go to particles. And here we have a text entry, and so we can right click on that, just like you can right click on all text objects inside of Dynamo. Yeah, that's pretty much where we're trying. And then we can go to DD browse, or you can go to DD slider. You can view these particles in many different ways. Here we're going to use this, which opens up a brand new GUI. And from here, you can click the show button, and you can get that exact same viewing functionality of your data folder. Alright, so let's say you want to look at just a few particles. Then if you're in the command line, and if it works on your Macs, then you can limit your particles to between 4 and 20.
That's why it's putting all the slices, all the particles together.
Alright, so then I can use the whole.
If you are unsure of,
It means projects all the slices.
if you're unsure of what your table is telling you, then you can type DT help, and you'll get table help information. This is also the same as the information that you get from typing dhelp and then clicking on the table button. And here we see, right, so we're going through the metadata in this tutorial, which we've already gone through already. And we've gone through exactly the shifts and the Euler angle orientations. So this is a rehash right here. And the Fourier type. So our simulated Fourier type is tilt along y from negative to positive 60 degrees. And so whenever you actually have a tomogram, you need to make sure, and you extract particles, always double check to make sure that you have the correct Fourier type and the type and the angular range that you actually reconstructed your tomograms from, so you're not including or excluding information that actually exists in your sub-tomograms. Okay. And we've gone through this already. I've been ahead of myself a little bit here, which is perfectly fine. Okay. And yep, we've gone through everything on this page. So we have our correlation coefficient after alignment. You have your tomogram number and where it extracted from in your data table, and any eigencoefficients from classification. Okay. So yeah, we can use DT show. So Dynamo has a few. We've already gone through dinfo. There's also DT show, so you can give Dynamo a table and have it show you different properties in that table, so different columns. So let's quickly go through that. If we are inside, where do we have a console open? Yes. So if we go to, apologize, let me remind myself, DT show, and then my test / we had a table called course.table. And from here, we're able to plot, this is a fake course aligned set of particles, and we can plot any given table value for all the particles One quite useful value is the tilt. So this will tell you if you have preferred orientation generally in your particle data set. So remember, this is in the ZXZ convention, this is the tilt along X. So this tells you if your particle has been rotated relative to the normal of the tomogram, which will, as I said, give you information on preferred orientation of your particle. And in our fake data set here, we have, even though we have 8 points, it's maybe roughly uniform. And you can look at, the shifts that have your particles have undergone. If you have information on how much your particle should or should not shift, then you can start excluding particles from your data set based on these restrictions that you have, either on dx, dy, or dz. You can also look at correlation, but we didn't actually align it, so that's an empty set of values right there.
How did you get that figure to come up? I just get a box with a bunch of choices.
You click on one of the
Which one do we pick?
buttons. I'm sorry?
How do we get that?
You type in DT show followed by the location of an actual table.
That's but then how do I get? That this popped up.
Were you in this directory? Did you
Uh-huh.
actually have that? LS, yeah, you're fine.
Oh.
Press up twice. No, not up. Okay, what? Do a DT show.
And when you have your project prepared, you just transfer the project to the running.
DT show course.table. Did that not work?
Figure 1 and figure 2 and 3.
Oh, that's interesting. So when I'm in the command console, so not Dynamo, but Dynamo X, it does work. So try the command console. So kill this Dynamo session, and then do Dynamo space X, and then try the same command in there, and it should work. Did you get it working? Okay.
Yeah. I didn't get figure 1.
Oh, yeah.
But then I got figure.
For whatever reason.
I didn't get that.
What are you supposed to do?
It's just hanging.
There's
Oh, yeah, that one.
another what Alex showed all
DT show view, and then what do you do? Ask me about stuff.
And then Z type. Just click on another GUI.
I think it's too many people on there.
And then there's
I don't really think so.
way to.
You don't think so?
do that
Yes.
So not doing something so intense.
That's true. I guess opening graphics is intense enough.
I think it's configuration that's not right.
Oh, okay.
Yeah, try to do all these quality thing might not be
I was using Dynamo.
See, it's just crashed.
view not table. Let's put it up.
Okay. So that then if you click on it, it'll pop up or something. And you switch it to that way. But I guess it doesn't work with Dynamo.
Oh,
That's why I had to switch to the other. Okay, you switch and see if the figure works.
Do you know which one? Sure. Database? No, yeah, something. List content. Let guess.
But did you get an error or did you just
Time for break.
It's close to time for a break.
So I need DT show.
We're just a
what
few
are
slides out here.
Okay.
Sorry?
Does that come up, or you ask me to choose a bunch of what it is?
even this in data check?
Where did you enter your?
No,
On
okay,
the command line
but you
with
didn't,
the
you never
right
got
key.
you just had a window.
I got that window.
Oh yeah? Okay.
What is it?
Okay.
I'm running on your computer.
My computer. Oh.
And then it's not X, that's all.
Yes, I've seen this. I don't know why either. So can you open up the Dynamo X instead of the Dynamo and then try doing it there? Let me know if that doesn't work.
Okay, sure.
Oh, I would, yeah, I would,
Okay. So this way of looking at your data after it's been aligned can be very useful, as I said, to determine preferred orientation, for instance. All right. It works?
Yeah.
Okay, great. Wonderful. You can also do dinfo on tables. So let's go ahead and do that real quick. It'll give you all the information about a particular table. So we already have part of the command written out. So just press up and fix your command. And then over here on the left, it'll give you all the information on this particular table, including means and median standard deviation of dx, dy, dz, your orientational angle, tilt, and x, y, and z, x, z. Also, where they were picked from the tomograms, any information that actually exists in your table. This will give you a nice summary that you can use for various analytical purposes. So it's useful functionality. Okay, deslices wasn't actually working in our version of Dynamo, but that's okay. What we want to show here is that we can actually view our aligned particles. So we know they're aligned in our table. How do we actually apply that to, I have so many windows open. How do we actually apply that to the viewing? So if we go into our Dynamo console here, open up DCP, then from there we go to load and we load our project. I already have mine loaded, so I'm not doing that. And then from here we can go to particles and we can right click this and then go to data browse. From here, then we can either look at our particles unaligned, and so we could just hit show and look at a Z projection of all particles. Or since we have an aligned table, let's go ahead and find that aligned table. So I'm going to delete this table, go back over here, may have to do it from this command line console, ls, we have, I think it's mytest/real, actually I have it memorized, so let's go ahead and do that. Hit enter there. Make sure to check this little box to say yes, apply these alignments on my particles. Then we show that.
How do we get the data browse?
If you go to your, in the GUI, in the work, the wizard, yes. If you go to particles, right here, and then right click the data folder, even though your data folder doesn't say it exists. So you need to solve your non-existent data folder problem. After you do that, then you can right click and select DD browse. So point it to the correct data folder. That'll work. So here we can look at the aligned. Here I can, I'll sit down with you at the break and we'll go through this. And so here we're looking at the aligned particles, and if you were here yesterday, I described why there is smearing in reprojected tomograms, because we have the missing wedge. And so here we have missing wedge orientation effects on different particles that had different orientations in the fake synthetic ice. All right. And here is exactly what we just did. So you can look at this at page 30 of the PDF, where we applied our real table and we showed that. Oh, yes. And you can also look at the properties which we did with dinfo inside of the visual interface. Let's quickly go through that. So we have selected our real table, and I believe if you right click on the particles, then you can look at table properties, and you can see the contents for any particular particle that you click on. So the amount of shift and the amount of various rotations. All right. And of course, this is a great functionality. You can right click, so remember these are projections of a 3D particle in the Z direction. We can actually view that aligned particle in a slice by slice viewer. And so that's what we have right here. We're looking at the Z slices of this aligned particle, and we can switch to the Y slices and the X slices. All right. Then there is an average functionality inside of the Dynamo command line, and so we can average our particles with a simple command. If you're ever confused about which or how the command is actually formatted, you would do a help on that function. So help daverage should give you all that information, and of course it does. Okay, successful call to. Yeah. Oh right, it didn't work in this version of the command console. Oh well. So we're going to use the command as it's written here. My test. So we're averaging our data folder given this real table. And we want to output that average to this EM file right here. Having an input error. Let's see. I'm going to run this same command from the non-Dynamo console version. And after we go through this, I believe we'll be at a break, so you can ask us questions, go get some food, etc. So daverage our my tests data folder using our, I believe you might have to have a -t. I might have missed that in the previous one. -t, and then output. And here you'll have the averaging function, which is very fast because we have small particles and only 8 of them. And now we have our average sitting right here. If we do an ls, and then we can open up another viewing function inside of Dynamo called dview, Dynamo view. And this, cross our fingers, actually displays. Excellent. Okay, so that's our average of our fake data, or aligned fake data. You can see in the X, Y, or Z directions also. And this should have missing wedge artifacts that are commensurate with the amount of tilt, overall tilt in your combined aligned particles. It's refusing to let me click the X or Y, but there you go.
12 particles, right?
Yeah, 8 particles. Right. Yeah. All right, so you've gone through most of the basic Dynamo functionality, and so we're going to, at this point, take a break. If you'd like to, you can sit down and go through other PDFs that are in your Dynamo/doc folder. All right, and we'll be here to ask, or you can ask us questions. We're going to get back at, what does the schedule say? Roughly 3:30, so yeah, try to be back by, let's say, 3:35. And then we're going to go through some sub-volume alignment projects. All right? And then after that, we have some real data, which you can actually go through and align on your own, as long as you wish tonight.
The people that are working with Macs,
Yeah.
are they having some problem with the interface?
I have both Dynamo X and just Dynamo to run certain things.
Yeah, I do have that.
Currently.
Same with Linux. There's a couple things that do work in one and don't work in the other. So the Dynamo console's a new interface. Don't blame Daniel. He's always working hard for you guys, getting Dynamo to work in every possible situation. So be patient.
Which of these
It does work.
PDFs might be good to look at this point?
So you may want to look at the command line PDF. Here I have it projected on the TV right now. And then the next thing we're going to do is introduction to alignment projects, or a similar tutorial. Yeah, so good PDFs in here. So it's actually on the website. It's one going,
It's not here.
no, it's on your other sheet here at the bottom here. So if you go to that website, that's actually what we're going to cover next.
But there are lots of them. Lots of slides.
There's lots of slides for every tutorial, absolutely. Huh? Now if you go to that particular URL, this doesn't exist on the website, but it actually is there. Out of these tutorials, I can give you good information here. You want to, so the Dynamo basic tutorial is more or less what you just did. Dynamo getting started, also good.
Okay. What about the next?
Express tutorial is also good, but it might be old, it might be outdated.
How about to prepare myself for 3:30?
For 3:30?
Classification.
No, we're doing classification tomorrow.
The latest version.
It's probably, yeah, there's not one that is explicitly alignment in here. No, manual is a different beast altogether. It's probably Express tutorial, but it's probably outdated. That's my best guess from my memory. Yeah, yeah.
Have you ever seen something? I don't understand what could be wrong in a system in which I can do.
So this is all.
Oh, it's on the Mac. I think it's what. Yeah. So if I could make a plotting order, it works. If I do it again.
This might be the issue. So remember there was a meeting something like a week ago where I said that the Dynamo, no, we're using Dynamo.
No, that is just Dynamo.
No, never mind.
So it means it forgot how to.
Oh, wait.
What can I mean, I checked the libraries, but I deleted
Is there a way to set? Yeah, that doesn't make sense. But in order to get around this, are you able to set it to display figure 2? Is there a command to do that?
Yeah, actually, but,
Does that work?
but I think that. Oh! Oh my god, that's.
What is wrong? You got something broken. That's right.
You're a genius.
I don't know. There you go.
Okay.
I don't know.
Okay, let's try. So, see
So this might have been part of the problem. So it's safe. That's all.
okay. No, let's try the
Clear figure.
CLF, the clear figure is
Same as that problem.
what's the other one?
Huh?
Matplotlib is the same.
Oh, it is? Is that true? I don't know.
I don't know. Let's do license. Data.
Yeah, I
Want
think
to
it's
see
just working.
his
This wasn't working on
practical.
mine either.
Ah,
And you will
well, that's great.
it's not that great. I mean, that's
That's annoying.
That's annoying.
You type figure 2?
Yeah, I mean, I create more figures, and apparently
finding
that's all.
There's
That's
a
all it
core
needs.
functionality issue.
I mean, when you do it with MATLAB, I mean, and you don't recreate a figure, it doesn't.
figure or
Nothing happens.
You guys know where to put it.
I think you saw that one.
Exactly, but it creates its
Just
own
like it was not
its own
changing
figure. I
figures
mean,
like
for
it should.
everybody else it works. I don't know why here it doesn't work.
Downloaded the same.
Exactly. I mean, but the thing is that you downloaded the same, but it's still using some part, some libraries that are in the Mac installation.
Yeah.
But
So the next part will be
Years ago, we used to have a Linux.
more what you were
We used to,
expecting.
in our EA workshop, we had one big project where we used the Linux libraries. And on the Macs, the one year I did Macs, it was nice, and this is really problem. The Linux was good because I had a boot disk and everything was identical.
But this was working.
yeah, it's strange because one would say that Macs they come from the same company, whatever. So it's so standardized. That's everybody's having different issues. And with Linux, at least they have the same. But not for us. Okay, and I guess that you will only affect when you are creating things with the command line, but normally when what we are going to do now is on the pipelines, the workflows, internally they call a figure, so that I guess that
But if I had this figure window open, would it automatically have a place to go?
yeah, it will.
Because like this did.
Yeah, so that we can even check, for instance, the data check now, and it will work because it will go here.
So the
And
X
the
counts
data
is
check.
sent to here.
There's the same thing average.
Oh, yeah.
So I ran it here and then.
Sorry.
Oh, no, thanks.
There's one.
Working, some problems.
But now it's.
No, I just
Oh, okay, good. Good coaching now.
But that's why I had both of them, because of, whichever one I was
So,
She was having like sometimes it would work in Dynamo X and not in Dynamo, but then now it's working both. She
Now
was
it's
doing like
working in both,
de-average
so-
and now it's happy. So we don't know exactly.
yeah, okay, then.
Random issues.
How do you get a track of what works and doesn't work?
In my head,
I
no,
can't keep
no.
everything,
Yeah.
I can't keep everything
I'm
straight.
not in debug mode
So-
right now. It's in presenting mode, sorry.
Okay. Well, after the workshop, as you can just tell me what didn't work.
What was that one that I was trying to do to display something and that box kept popping up? I think that was the other same issue. What were these slices?
I don't know.
You know what it was the one with the images. We were trying to display the,
Just like 8 particles.
yeah, just to display that, or having a box that popped up an option, no matter what I couldn't get to.
Oh,
that.
yeah.
And that was when we were trying to do it,
Okay.
command line, I think.
Forget the name.
But you don't have any macro?
No,
Really?
well,
But this
we
is.
do. But
We have MATLAB 2012 on the cluster only. It's not on the.
Yeah.
Well, no, that's,
I know.
That's bad.
That's bad.
It's not gonna help.
No, I mean, it's much worse on the standalone. But
Yeah. So.
Yeah, so no matter.
Sorry.
Okay. No, it's okay. It's okay. I mean, that's. I'm always saying that Dynamo works as a standalone. I have to prove it.
So for most of my Dynamo career, I've only used standalone.
Really?
No. Like FSU, we only had 2010, we had 2012, and then we had, I think we had 2014 at one point at the end. So I standalone, almost everything.
But what is not working in general with the Dynamo X? Which kind of thing?
Sometimes like D-slices didn't work for me, I don't think. There was, let me go through.
These slices in
No.
Oh, it was DT show.
DT
The
show.
course table. That's
Yeah.
That's what wasn't working
Yeah.
from the command line.
That's right. I did see that on a couple computers. That was just giving a like option, opening options. Strange.
This comes out.
Oh, okay.
And
That's,
then we couldn't figure out how to get from there
yeah, okay, no.
versus immediate
Okay,
display.
we'll go to presentation. The thing is that this console is not exactly the same syntax as this console.
Okay, so
So
that's
that,
what we're doing.
yeah, it's
So that's the only one that was glaringly, different.
Mm-hmm.
Okay.
Yeah, I mean that in this console, whatever has to go to MATLAB and not to Dynamo goes to // So for safety, always put a slash, a backslash, and then it will go to the correct
Okay.
place.
Okay.
Yeah, I mean, sorry for all this confusion. The thing is that these things should disappear at some point and everything will cohere in this transition
Yeah,
period. There is
no,
some
that's-
entropy
no,
that.
that's fine.
But I mean, next time you have this kind of problem, just
Try that? Okay.
and then
Alright,
and then you can protest.
Okay. Yeah, I'll make that. Thank you. the only one I actually remember, because other people had the same issue, but I think there was.
And in the other direction, I mean, things that do work in the console, in the X, and do not work in the shell. That's what the. If you can remember this kind of errors, then tell me, because that's what is very interesting for me. Because my goal is that the shell means that this floating X window can do everything.
Yeah,
So
yeah,
that's-
sure.
So actually, so I got to a point where I had too many windows open, and then I X'd out and had to like start over.
Mhm.
But so I got lost. So now I just have to follow the tutorial. But the GUI is actually very intuitive. Not intuitive.
Really?
Well, following along.
I
Sorry.
think you're the first person that's it.
No, but following along with these tutorials, they're very clear.
Mhm.
So I loaded my project, I think.
Yeah, you create still.
It tests, so it's okay.
Because that's what you're going to do.
So they're all the right size.
So,
They're all the right size, right? That's all you're checking for?
yeah, I'm checking that nothing really bad happened. For instance, this. With the standalone, there are the main things work. I mean, all the creation of projects and running projects, all these things work. But especially this part, the visual part with the GUIs.
Drop off
I
grids.
mean, I was able to look at like a full panel also. It's just,
Yeah.
the particles I was looking at just look very different. So I don't know, I think there's like processing
That's
stuff
like amazing,
that they
right?
do.
Okay. With the
Wow.
talk on
Is
the
that your dad?
No, that's your data. Right? This should look familiar like from here to here.
Perfect.
But it's annoying because everything you were going through was, you have to say this Dynamo X, no, this is Dynamo, and Dynamo X displays this.
Yes, this is a
It's
new
Mac.
anti-feature.
Anti-Mac feature.
Oh, we figured out the, it needed this
You
to
should
display.
have created
Oh, do I need
If
to
it needs
load?
MATLAB,
a
that's
report.
what
I
the
have a
hash.
funny D-show.
work. And do you have a MATLAB
That's,
installation?
that's what we're saying, that we have to add that.
So you should have alpha test it with one of us before. Next time we'll alpha test it and then make sure what's broken, you know, silly things like this.
Yeah, yeah,
I mean,
definitely.
the main things are there.
So we usually
But
do
all
a
these
workshop
small
about
details
the-
that I like to show.
Yeah,
I
no.
did. Okay.
Yeah.
But I mean, I should be fine to continue in the line.
Who knows?
Yeah. I mean,
Don't
the main
worry.
things are tested. What
So
I'm
this is-
looking now is
This
This
is
is
even
on
better.
par.
And the
This is on
report
par.
is
You're
just a
even
means
better.
of tracking, like in real life, not
It
this,
works.
but it's just a
Everything
means of
you've done
tracking.
actually works.
Well, there's a way to do it.
this report that we are missing.
There's a will.
We can still get it.
I mean,
in the-
I guess it's good in a way
from the
that I can
command
show you
languages.
all the different ways you can get to such and such a window.
Right. Through the GUI, through command line,
Through
through
the other
So
command.
it shows the right turn both ways.
Yeah.
I
Yeah.
do.
That's the least fun part of the workshop for everybody.
Just
It's like they're-
debugging and learning syntax.
syntax and format. Yeah.
Okay.
You should just take a pizza for the.
Oh.
This one wasn't working, this is where I got messed up.
We're having eggplant. on
Yeah, apparently-
salads.
And that's why I exited out.
I see.
Well,
Apparently,
only for
this
the people registered.
standalone in the
We
Mac
don't
is
have
very
enough for the whole
temperamental.
Yep.
So that what
We
people
have
are
enough
doing
for
is following. There are a
the
couple of
room plus
graphic
converted
things.
and
We'll check.
we didn't sign that. Meaning if all of Sensei came in, there would not be enough food.
Someone's gonna have to lay down the law on that one.
Oh, what did you do?
Yeah,
The installation.
so-
Okay.
Sorry, so desktop,
It's in desktop. Okay.
it's a desktop slash Dynamo local.
So I could do this. So why did you go into my just check
For which part of
Got the project right here, guys. My test.
Did I close everything? I don't have the background.
Yeah, the thing is that I swear that is
So I'm not sure.
I swear to God that is a bug of MATLAB. No, and the thing is that the newest MATLAB libraries are not very good at understanding the interaction with the tools. So that that's what I was saying before, that the main functionality is there, but these small things like creating some figures that are not explicitly created here.
But this is okay, I mean, until it's like whatever sorted out, this is an okay workaround because I was actually processing my data. It would just be to open the other version and open it there.
Yeah, yeah. Yeah, it's really annoying, but well, that's what you didn't see, I guess. I mean, this data check is just going particle by particle, and just looking that you don't have all the numbers, you don't have the particles from actually same size. Because it didn't take a lot of time because we are but it happens a lot of time that, for instance, when you are transferring a lot of files from some part, and you launch your job, it enters the project, it enters the cluster after a lot of waiting, and then the project just crashes because it found some particle that is corrupted. So that's why it's good before launching a project, just checking that everything is okay. I mean, not everything, but at least the data does not contain corruption.
Cool, great, thank you.
So that if you have more problems when or Alex says you should see a window, and maybe use the.
Okay, perfect. I'll minimize this so that I
It's
don't
all
have to go there.
What the good news about all of this is that I have my own bug reporting. Seriously, there is you go to the MATLAB web page, you see this error
No, this is all tested.
in the track of the user.
On the MATLAB webpage.
Yeah,
So it's all
I mean,
never
done.
So
They,
they-
yeah, they have this track of this
Yeah.
bug tracker
That was kind of
from users, and I am 2000.
Are you
Well, no,
Two
gold
to five.
member?
No, I mean I think that
Average.
well, I think there is just the fact that they assign me the number 25,000 or something like that means that
That seems to be
there are a lot of bugs.
Yeah.
Well, no, it's probably because I'm.
So we're not
this
alone.
is a-
Everybody's code is bugs, even the big companies.
Oh, really?
Oh, yeah.
Billions of dollars.
Oh
Everybody
yeah,
has
oh yeah,
bugs.
oh yeah.
That makes me feel better.
Oh yeah, yeah. No, I will show you. I will show you my bug. I will show you my bug in the.
Yeah.
Okay, now what we are doing afterwards? I mean,
Okay,
I will do my typical.
Yeah, if you're okay with that, then
Do you want to do it or?
How about-
my voice isn't.
Okay.
My mouth.
You really
Yeah.
want
Switching, I think, is a, maybe we should even do switching in Basel too.
you should do what?
Maybe we should even switch in Basel too. It's up to you on that.
I actually.
I don't know. Talking for you talk for like 10 hours. I don't know how you do that.
No, I hate it. I mean, the first year was okay. The second.
Yeah. So this tutorial, and then so here I have my VNC type thing right here. And let's see, we just have a bunch of projects.
Yeah.
Just do however you want, I guess. Let me close up some stuff for you.
The problem is that, I mean, if I use Dynamo and not Dynamo X, the windows are not going to be responsive. You have seen that already, no?
Yeah, a little bit.
Okay. I will.
You can, if you want to run from your laptop, you can do that. Now it's up to you.
Well, in my laptop, I can just. No, the thing is that you have the PDF already here, so that it's comfortable to switch.
Yeah. True.
And also it's good that I suffer exactly the same as they do. But,
So how is
All right.
No, so it's a protein complex, bacterial phages, and complex with the bacteria phage closely sliver. I was having issues with single particle. It's important to build up on signal symmetry, and the helicase loader, there's no structure for it. And also, the stoichiometry has some issues with that particular. So it's structurally heterogeneous. And I was having a lot of issues with that between NRAMMs, generating an initial model of that, because I could never get a reliable initial model for it. And then I back projected it to use that as templates for tuning the auto match. And it worked wonderfully. Yeah. So I have the overall resolution of the map right now is 4.02.
4.
4. Maybe crash, but it's 4.
Even if you round to tens, it's 4.0.
I don't want to be cheap. But yeah, so some areas there's higher resolution than that, and some areas are probably lower, so I'm just doing requirements and
So there's
model.
no loader structure in X-ray structure for the loader?
So there is a structure, so the helicase is a hexamer, heterohexamer, and it's bigger, in solution inactive. And then there's a low resolution structure of the bacteria helicase liver and the helicase. It's like a 25 angstrom neon volume. So they report that cracks over the brain before loading. And then there's another structure.
Wait, 25 angstrom.
Yeah, it's
Wait.
super. Sorry,
like
the
50
resolution.
Oh, I'm sorry.
Sorry, yeah. The
It's like it's bigger than
DC.
this.
Yeah, so then there's a crystal structure, like 7-ish angstrom of it loaded. And at that point, it doesn't return to the cleaner, it's still cracked. They're trying to figure out.
So in your case, you can see the crack.
No, so there's a total crack.
Broken one.
Yeah, good idea. Exactly.
It's not a circle. It's a broken line.
It's just screenshots.
So who saw that structure of the saying the liposome or semiconductor? That's the guy?
With the liposome.
The liposome and the GPCR in there?
Julia Brash's structure? The one that's,
He showed the liposome structure
GPCR.
in stuff, right?
No, in the meeting,
In the meeting, you were showing the liposome.
Daniel showed a GPC.
You showed a lot of structures.
No, there was only one. Two
Oh,
he showed.
oh.
One was,
No, I don't think there's anybody here. I think there's anybody here.
no, not from here, I think it was. I'm asking, Daniel, the GPCR liposome structure was from this micron position. Is that something?
the 5HT3,
Yeah. So it was published in the
yeah.
So it was, how was that? I mean, how long they owned that? It was difficult? It was easy?
It took some time to create the tool, but when the tools were there, we breezed through the data.
Let me see, but the sample preparation, that was easy?
Oh no, that's not. But that's not my problem.
That's not-
That's Misha's problem.
That's
I mean,
not-
the computational part, once the tools that we wanted were there. The preparation part, I mean, I know that Misha suffered quite a bit, but I don't know. You can just contact him.
I will contact him. Yeah, I'm going to listen to the thing, but not on the liposome, but on the virus part.
About
On the virus part. GPCR. But we did it on the liposome, but I want to do it on
Okay, let's see. Yeah. So here I just open up in this tab, Dynamo X, and this one, regular Dynamo. So that's all that we have.
Okay.
And then we have those random projects.
Okay.
So,
And
then if you move this full window, the VNC, to the left.
what you're
Yeah,
doing?
yeah, right here. Just move the full
Oh,
window to the
wow.
left.
Okay.
Then we have the PDF. So that's
Okay, so
page
that
back, forth, back, forth.
so you haven't prepared this presentation, perfect.
I prepared. No, I didn't prepare.
Using that to
Ah, that's my presentation.
Cheers.
It's honestly, it's made a difference. So now I need to learn how Alex processes this data. So for the future, try.
Is that right after this? Or do you think we can have
When are
it
you
tomorrow?
on again with the
Before her
DA?
PhD.
Huh?
Before her defense, PhD defense.
Oh, I'm just in my third year. Yeah, I have a while
The fall
left.
now. You think that would be possible? It's
When are
great.
you on the microscope?
Katie has time in January.
Did you see that thing?
But, yeah, I don't know. That's the problem. So what I'm trying to do is
Response now. I don't
prep
understand.
some stuff. Either way, I'd like the time. So I need to figure out who I have to sleep with. Paul Gottlieb's and stuff all of it, but if I can't get the stuff with DNA ready to go, then I'll just try to make some good this again and try to get better. Yeah, well, more tokens.
Awesome. Awesome.
Fingers crossed.
Hey, Ash, who,
So in your case,
does anything in our lab do modeling? Like, which
We don't do flexible fitting, we do rigid body docking.
well, everybody does rigid body.
Yeah, so everything is exactly the
I've done
same.
MDFF in my life,
One thing
like
is,
once,
so I use cold
and it worked, and I got a
grids,
publication,
I use
but
and then for the
I don't know if I'm an
tiny grams, I
expert.
use small
No.
spacing
It's,
because there's any dosing.
Yeah.
I mean,
Okay.
Oh yeah, because before, he's
pretty
like,
nice
I think I did
modules,
something
high
Sorry,
modules,
horrible.
and
That's
trying to
the-
generate
It's okay.
images.
I have a bunch of windows open in here.
So they
Yeah,
list
it's crazy because you're working with two desktops at once.
and
Okay, how do I change?
So, yeah, perfect. These are the two Dynamo windows that we have open.
Okay.
You can, if you want,
went to a different
Okay, no.
kill any excess windows that you don't want
So it
in
was,
your
and I don't know
workspace.
if it
That's
was enough.
Okay, so that they come back, and then, yeah, I think we will. But okay, so that's this is a second desktop. Okay,
down there. This is the next.
okay,
Those models
Here, let me-
differ from
okay. Let me see. Yeah.
Let me just get some of these out of your way.
1,000 variables. So each of these, although they're not super pretty, each of these is only.
it's on the table.
Okay, so we have one website, and then do we need this?
FEI.
Yeah, so we need to.
No, we don't need this.
Angie.
I think the tomography aspect of the interplay between
FEI was us for the.
Okay.
And I mean,
And
last one,
we don't need this.
Wow.
Bundles.
We
That's
use
all.
bundles all the time.
No. I was just opening it for an example. Okay, there, bare bones.
Let's do a charge back to FEI.
especially because
Okay, we should start now.
I push for this, and you didn't understand.
It's not yet.
I don't know where they are.
Okay, let's give them 5 minutes.
Yeah.
He's very hesitant.
Sorry.
If you have a D even symmetry,
And then there will be the storm.
then you also have an inversion.
Wait, you're at Scripps with present?
We should be, yeah.
Yeah,
something
yeah.
like that.
Yeah,
But-
even because I was in meetings and stuff.
I had an internship just down the road at J. Merrifield Road or whatever it's called.
I have to think what to do
Quite a
with
few
the
years ago,
tilts.
but
I
sort of
can, I know how to
it's beautiful
symmetrize
area.
So
the z-axis,
So,
because
yeah,
that's
so
a
what
51
this one
degree
is
shift
just
to the 7th, but I'm not quite sure what to do.
they express the
How to symmetrize
and
the
then
tilt.
and then what they calculate the favorite feature.
Mhm.
And then the methods,
To get the D.
how they express it. That really makes it better.
Because if they don't really worry about it, they just cut this through in half and then
What I'm
just.
hoping for physics, but I need to get the
Right.
biology.
Well,
and
I mean,
to
you
get
see,
the
for T6,
structure
and you're
there,
just
and I was
talking about the
asking
information
Alex
content
earlier.
of projections, you don't
The
have to
modeling
do
is,
that
even
D
though
and
the
C
density
then.
map is really good,
The R,
the
I
modeling
think,
is
what
challenging
to do.
because there's so many components
Good.
and then one tertiary complex there's no real structure for it. So I don't want to mess up. You know what I mean? Like it's.
So Ed said that Rockefeller has people who are good at flexible fitting.
I could just email Rich too. Rich Knight.
Just talk to Rod.
I know. Well, I just don't want to be annoying.
You're a PhD student. That's your job.
And Seth First also has done quite a bit of microdynamics. They're both on my committee, so maybe I should reach out to them. and see if they
Yeah,
can
they're on
stop
your
by.
committee. That's their job.
Just- How's Dina with modeling? She up for a no, she's fine. She doesn't mind that.
Yeah, but she's good in
Let's look at the software side.
It's weird.
What?
It's weird. You're clicking and it's not doing.
Yeah, I mean, that's the bug tracker of MATLAB. I mean, they told me they have solved it. And they did. No, it could not. It's totally impossible that it works for you. Actually, I think we have to exit Dynamo and enter again. Okay, we're a full house
No
now.
one has been assigned because politically
One or
they're
two people, but pretty much
As bad as us.
as bad as anyone.
You're the boss, you tell me.
I don't know, understand that the situation is, I'll let them sort it out.
Like, yeah, brought grapes. So.
No, I'm
Just joking that
We're just joking.
they've used a few of ours.
So we would clip a couple of grits and they're in the Krios, but who's going to pay for those consumers?
Now they can give us a face grade.
You've been here in 30 seconds. He's actually making grids.
I mean, it's all the
Okay.
same size, right? Playing face
For
grade,
immediate
I think
processing.
it's a bad grade.
Okay, what is a fast way to locate it? Ah, it's here.
Yeah, you have two.
Yeah.
Okay.
No.
Alex, Daniel, I have to leave a little after 4.
It's a little after 4.
Yeah, so I'm letting you know so that at that time I'll just go out, walk out.
Okay, not
Yeah.
that you're just terrified and
Right.
escaping
I don't
away.
want you to think that I'm walking out.
Okay.
Yeah,
No, it's-
and
well,
I'll
it's
catch up with
liability.
you later.
Oh, Bill, did you make any decisions about the payments? Because I reached the,
Okay,
But for my grade,
No,
I lose the PDFs.
So this is in the Linux. So if you
Ah, yeah,
hit
it's
the
in
top,
the,
and you move it to the
I
left.
forgot it.
That's a little weird, but
Yeah, it's, yeah, whatever.
it works.
Okay, perfect.
Okay, you're good.
Yeah.
All right, we're gonna get started again. To save my voice, we're gonna have Daniel work through the second part.
Yep.
We're going through the sub-volume averaging pipeline, the workflow. So this is essentially core functionality of Dynamo. So this will be useful for you.
Yeah, well, okay, the first part where we presented, or in this case, Alex presented all the core metadata and all the hard facts is normally very, very boring. Good news is this is going to be even more boring because we are going to go in a very detailed level on all everything that you have to take into account when you create a project. But I promise that from tomorrow on, it's a lot of visualizing tomograms and just using what we are going to see today. So let's start. So we open the manager, DCP, or you just go to Tools and open the wizard. In any case, what I want to do is I want to go through the steps that you need to do in order to create a project. In this case, we have already created a project, and we are going to see on the project that we have created in the tutorial, because you are already familiar with the data and the table, so that now we are going to see how these concepts map into the Dynamo window. So that when you open the Dynamo window with DCP and you choose not to open it onto a project, the project area is empty, so that you just import the project, pick from projects in this directory, or this ptest. So when it is blue or green, it means it's computing or it's doing something. So don't click out of impatient all the time, because you really have to wait until you have black letters on a white background, and then Dynamo is ready for instructions. Okay, and what we see here, these input files, is exactly the order in which you input the different elements. In this case, this project has been created already by Dynamo, so it's correctly formatted, so we can follow it. In real life, you cannot enter one stage until Dynamo is happy with the input from the previous stage. So that Dynamo is internally checking that everything that you're importing makes sense, that the dimensions are correct, and that you are not doing anything very wrong. So that, let's see. Here, the first thing that we did is we defined the project. Then, by definition, it's a project with one single reference. We will see tomorrow how you can multi-reference project that align and classify on the same time. And then the next input area are the particles. If you feel lost with what I'm doing, don't worry, because we have this PDF that is doing exactly step by step what I'm going to present now. So that the idea is that we will do it together now, everything here, with a lot of level of detail, and then you will take some time to work using the PDF to reproduce what we are doing now. So that let's start. Particles. And here you have two options. Normally, when you are in the stage in which you are using the DCP, the wizard, for creation of the Dynamo projects, normally you already have a data folder, so that you just import it, write it, or drag it, or whatever. And there are a couple of things that you can do. You can check the contents of the data folder to see. Okay. And it gives you back the information that Alex presented in the previous part. It tells you that okay, that is a data folder. Those are the tags, and so on and so on. The technical specs on this folder. If not, Dynamo will give you some options to use other tools to extract particles from a tomogram or from a catalog or from any other source, or to convert it from some other data storage convention. But normally, as I said, when you are here, you normally have already created a data folder. Then you will go to the table, and in this case, in this project, probably it has created just a blank table. I just click on the name of the table. If I go to the basic information, I see that Dynamo is telling me, okay, there are 8 particles, and the shifts and the angles, the initial shifts. Sorry, it's yeah. Okay, what I'm doing. This was already created because it's a project. I can go to inspect, and there are different options for inspection. General info or plot orientations. Those are specific options. But in Dynamo, what you almost always can do is you select a piece of text and then right click. Okay? And then you have Dynamo identifies the text as a table file, and you have different options. So that's a general utility. In this case,
what's the Dynamo linker? I don't get that.
Sorry?
Yeah, but like, what do you click on?
I think a lot of us are
You put the mouse there and I think
a lot of us aren't at your point. A lot of us aren't with you.
They are not following. Okay.
I'm not.
You're not following. Okay.
We haven't gotten to match where you are right now.
Okay, if you get totally lost, don't suffer that much. We are going to do it with a walkthrough after that. But again, let's do it smoothly. I'm here in the table area of the wizard.
Which table? It's the top wizard. For the wizard, we start.
Okay, this is the wizard. Here, it's everything that has to do with this project.
Right.
So that what we are doing is going step by step.
Okay.
We visited the particles.
Right.
And when the particles were we checked that the particles were okay, and then I clicked on table, and I got this other window, which is linked input initial tables for project ptest. So it's this table.
This table.
This this window is telling me all the information about the table related to this project. Okay, and what this window is telling me is that in this project, the table that I already have there, that I already have linked, because this project was created by the tutorial, is called mytest/initial.tbl. So that what we are doing now.
This happens occasionally.
Yeah,
on
with
different operating systems.
Yeah, probably it's because the screen is too small or something like that. And,
it could be your screen resolution.
Yeah.
But I've seen this before, and I have never found a way around it. So.
No, there is no bigger screen. That's another.
Yeah. Your
Sorry,
laptop's too small.
So that maybe some of you are only seeing part of this window. I think is that Dynamo is conceived to be used on a big screen, so that maybe you cannot rescale this window. I will solve that in, in the next edition, but now just bear with me. Here, all I'm doing is showing you how you interact with this window. Normally, the table that you put here has been already created by Dynamo, because you're using the catalog. If you are extracting particles with the catalog, Dynamo will give you a data folder, a table, everything. Here, I'm just making you familiar with ways of getting information and putting information here. If I don't know what is inside this initial.tbl thing, what I can always do is right-click on it. You cannot, but you will have you can just go to inspect. Yeah, and then I go to table info, and it's giving me the information related to this table. So that Dynamo sees this file as, okay, it is a matrix with 8 rows, 8 particles, and 40 properties. And then it gives you a status of all the properties. And it's telling us that this table is marking everything for alignment. So it's telling, I want to align all the particles that are here. The initial shifts are 0. The initial angles are 0. That's not always the case. For instance, when you are working with particles that come from a membrane or from a filament, you normally have already some angles. You have already some information. In this case, we are working with isolated particles, and we just want to show you what is the format that Dynamo is expecting. Cross correlation is 0 because we haven't done anything yet. The Fourier sampling is the same for all the particles. It's type 1, meaning that the beam comes from Z and the tilt is on Y, and there are some information about the missing wedge. So that you see that, so that you can identify if something is going definitely wrong. For instance, if you see that your Y tilt range is from 0 to 0, means that, okay, I never initialized the missing wedge, or something like that. But in this case, we are happy with what we see. If you don't have a table at all, you can just initialize it. You can create a new one, and it will automatically have the right format for the data folder that is already linked to the project. That's why you start with the particles, then you put the table, and there are different utilities that are convenient when you are working in multi-reference. But now,
we override the one that's correct, then if you accidentally click on it.
And here?
Yeah.
What happened?
It will make a new table, name it
So it has created this blank.tbl.
You won't overwrite that, okay.
Yeah, exactly. So that the thing is that it will probably very similar to the one that we have, because it's basically the same. I mean, it's a blank table, means that it doesn't have shifts, it doesn't have rotations, and everything is are default values. Okay, in the checks, there is also the consistency with current data. Maybe it won't work in the standalone. Oh, okay, it works. Yeah, telling you that okay, how many particles are in the data but not in the table, how many are in the table but not in the data, so that you always know that the metadata and your data are coherent. Because sometimes you actually want to run projects with a metadata that is a restricted version of the data, so that you have this the option here to check what you are doing. So that after checking that everything is the way we want, we move to the next stage. I mean, we have finished with the table, we move to the template. And we link whatever we want to use as a template. It can be a geometric shape, it can be one of the particles, it can be a lot of things. But one of the most useful ways of creating a template from the very beginning is just to average a random subset of your data. If you do that, you shouldn't use a lot of particles, because if you rotate particles randomly and average all of them, what you're creating is something like a ball without features, and you're not helping the alignment. Normally, if you just take up to 50 with different rotations, you have enough coverage of the missing wedge without rounding the initial template too much. That is one option. In this case, I think this template.em is just a band-passed version of one initial average of the original template. But in any case, okay, it's a little bit slow, but it comes. Yeah, we can take a look. Yeah, in this case it's a band-passed cylinder, because we know more or less what we are looking for. Okay, so that there is a template here, we can put import there, just copy and paste or browse for whichever folder you want, whichever file you want. If we are working in multi-reference, we have to put the name of a folder with different templates inside, but we will see it tomorrow. In any case, so we move to the masks. And that looks a little bit overwhelming, because why do we have so many masks? They are different things. The alignment mask is defining the part of the template that is going to be actually active. It's the part of the template that is going to use to that is going to be actually compared against the data. The classification mask is active in multi-reference project or in PCA project, and means that if you know that the heterogeneity that you're looking for, the conformational change that you're looking for, is restricted to a part of the tomogram, of the subtomogram, you can create a classification mask that is smaller than the alignment mask, and is like a magnifying glass on that particular part, on that particular area, so that you still use a big alignment mask in order to have enough signal to drive the alignment, but you use a smaller mask on your region of interest to boost your classification ability. The Fourier mask on template is a rather advanced feature. Normally, you can just use the fill with ones option, This Fourier mask on template means that if you are using a template that has a missing area in the Fourier space, normally you will pass the missing area as zeros, but then you have to tell MATLAB, to tell Dynamo, okay, what these zeros are not zeros, are actually missing information. It's not the same to have a zero and not to know what is the real pixel. It's very different. This situation happens, for instance, when you derive your template from many particles that are looking in the same direction, so that you are not giving the template a chance to actually fill the missing wedge, and you have to parameterize it. And the Fourier shell correlation mask, I normally just put it, just fill with ones. This means that in some of the workflows of Dynamo, you can use this golden standard situation in which Dynamo automatically splits the data into halves, processes them separately, and then it measures the resolution in order to band pass the next average to that resolution. That's the regular golden standard system. In this definition of golden standard, you have to compute the resolution somehow. You need an estimation of the resolution that you're getting. And this estimation comes in terms of the Fourier shell correlation of the half averages. This FSC can be very different depending on the way that you mask the two half averages. So that here I will let the user the opportunity of saying, okay, I want to measure my resolution exactly in this area of the average, and I know what I'm doing, so that I want to put a Gaussian or apodicite or whatever. In general, I just use the fill with ones option in order to avoid any interference with the FSC. And for all of them, you can use the default mask and then correct them one by one. That's what I'm going to do now. I use default masks so that it creates probably ones for the smoothing mask and ones for the correlation mask, and probably it created some sphere for the alignment mask. We can check it. We know that if you right click on a file, you will get this menu of options. So let's view it. Yeah, it has created a hard sphere. There are some options here so that we can create any other shape. I just clicked. Okay, let me make a little bit of room here.
So usually the main Dynamo window jumps up in front of the other Dynamo window. So I usually move that to the side so that it doesn't obstruct whatever I'm doing at the time.
Okay, this is a basic mask editor in which you can define different geometries and check how they look on your template. For instance, here what I could do is I could create a cylinder and put it a couple of parameters for the cylinder. A cylinder is defined by the radius. Let's give it 18, and the height, let's give it 36, so that I create the mask, a cylinder with these parameters, and then I try to show it. So here okay. Here in this case I took a cylinder with a radius of 18 pixels, a height of 36 pixels. I created the cylinder with these geometrical settings, and then I would show overlay and show the Z direction, show, and now we see how the cylinder is actually fitting the original template. Let's take it a look on the Y direction. Yeah. And in this case, you can, when you are happy with your mask, you can go transfer mask to wizard as alignment mask or classification mask or whatever mask. For instance, if we want to transfer it as classification mask, it will be there, so that it's it has created this editor mask, which is which we can check again. And no, it's a cylinder, not a sphere. So, okay. Let's say we are really happy with our mask. Now we go to the numerical parameters, so that we have linked all the files that we needed. Now we are going to start doing some.
So before you go there, when I first started using Dynamo on my PI, I was always really cautious about using hard masks, but you use a different mask alignment algorithm.
Yeah, the thing is that should I explain it? Okay. Normally, if Alex is right, the first time that you see that in Dynamo we are using hard masks, it looks like okay, that cannot work. The reason that it works is that we do not apply the masks on the templates. I mean, it's never that you have a full mask and then you apply on the template and that's it. The application of the mask on the template is code inside the Fourier transformation, so that all the artifacts that you get because of the hard edges that you put on the template are not there. I mean, it's a technique that is I don't know if it's very used in the single particle, but it was published some years ago, and you actually see that you don't get any kind of artifact. And actually, that's the only way that you can actually mask things properly, because if you mask a template with a mask and then compare the full mask and template against one particle, you're not modeling your problem in a correct way. What you want to do is to mask the template with the mask, extract only the pixels inside the masked part of the template, and compare those pixels with the equivalent region of interest in the subtomogram. That's conceptually very different to comparing a masked template with a particle. And in order to do that, the only way to do that, the only way to mathematically translate this process is with a hard mask. Okay, so that we have our hard mask coded into Dynamo. We have imported our input files, and we are trying to define some iterations, or at least we are going to explain what are these iterations that we have here. They look quite horrible the first time that you see all these matrix of parameters, but don't worry. First of all, you can go for the predefined profiles, so that if you know something about your particle, you can let Dynamo just make a guess about how to fill these parameters. But in this case, let's see what is happening. The way Dynamo works is with rounds of iterations. So that in this case, in the first round, we only have one iteration, but normally in a more complicated program or in a more complicated project, you would have many iterations on each round. And different rounds have a different conceptual mission here. In this iteration, we are going to explore first what is happening here, the angular refinement. This cone aperture, consampling, azimuth, refine factor, all of them are the angular parameters. Actually, what we can always do is just isolate the what we want to see. I mean, if we just want the general and angular parameters, we see that there aren't so much. And let's start. Cone aperture. What does it mean? It means that the way the cross correlation works is the following. You have a subtomogram, okay? That's a data particle with has whichever orientation. So that in this first round, this cone aperture is defining all the directions that the template is going to be rotated and compared with the data. That is the aperture. The sampling is how far away are going to be the different orientations. I mean, the sampling density. The azimuth rotation means that for each one of the rotations of the template, how many azimuthal rotations around its axis are we going to do? And the sampling is the same. The angular interval between different rotations. Another refine and refine factor. In Dynamo, this correlation happens on a multi-grid system, meaning the following. We have 6 refinement levels, what means that on the first pass of the template, it will check every 60 degrees on a cone of 360 degrees, the full sphere. So it will create a cross-correlation value from this orientation, this, and it will locate the orientation that gives the highest correlation. Let's say it's this one. Then it will refine around this orientation 6 times. Refine factor means that it will generate a small cone that is twice the size of the previous interval. That looks very strange, but don't worry. All this information is basically there. You can always click on a parameter, and you get the explanation on what it means. And we can always just make a sketch of what is happening. Okay, I'm going to sketch. I just generated an image of how the scanning procedure works for this parameter definition. So here the dark blue points, they are the original scanned orientations on the coast level, and you see that they cover the full sphere. At some point they find a maximum, and around this maximum they scan again and again and again up to 6 times, and that will be the final correlation. Okay, so that let's see what it means in our iteration strategy. Here what we're doing is, in this case, as we know that our particle should be something like a barrel, because we have some kind of familiarity with the data, we use one round in order to look for the orientation of the axis of the barrel, and we don't care about adjusting the azimuthal range of the barrel, because in this round we are just happy to get an initial alignment, an initial orientation. Also, our particles have a size of 64 pixels. In this first orientation, we're just using 32, because we are not going to create a great average. We're just interested in the initial orientation. In the next round, we restrict the cone aperture, because we assume that in the previous round we have found the general orientation, and we start with an azimuthal rotation range. In this case, the range is only 45 degrees and not 360, because we are really imposing a symmetry. The C8, so that we don't need to scan the full range because it's symmetry. And after these two passes on the low resolution, we go for the final pass on higher resolution, on the full resolution of the particle, on 64 degrees or 64 pixels. Yes.
So if you uncheck the thing, does it mean that you don't use it, or just that you don't see it?
You don't see it. I mean,
Okay,
the Dynamo will use everything that is here.
Okay.
So that, and the other important part are the limits on the particle. I mean, here, as it's just a synthetic data set, we don't want to. It's more or less the same. You don't put limits, but if you are working with membrane proteins or filaments or things that are continuous and not isolated in a box, you really have to tell Dynamo, okay, I don't want to let my particles wander away from the center more than so many pixels. There are different policies. In this shift limiting way, the policy 0 is I don't care about about the limits. But basically, the two policies that you may have are 1 and 2. 1 means that you are totally certain that your particles are good centered, so that the limits are measured from the physical center of the particle of the box. The policy 2 means that no, I think that the particles have been located in the table from the previous iteration. So depending on what you're doing, you want to use one policy or the other. For instance, policy 2 is good for from the very beginning in a project. You just see what happens if you let the iteration go its way. But when you are doing a subboxing after that, a subboxing meaning that you have already run an alignment and you know where the subunits are, and then you crop them physically in the real center, then you tell this certainty to Dynamo, now I really know where the particles should be with a precision of so many pixels. So that, remember the shifts. The shifts are the main reason that, okay. It's frozen.
No, you have to use the mouse stand.
Oh yeah, sorry. It's the main reason that normally you do your first Dynamo project on real data and you get just noise. Normally that's because you forgot about putting some shift policy and you just got membranes converging to each other or some random artifacts. Okay. And there are advanced options that probably we will take a look tomorrow because they are linked to different geometries. By now I would say that that's all you need to take into account, how you create your angles and how you create your shifts. So we are moving to the moment that we want to actually run the project. Here in the estimation of CPU time for current parameters, it's a good idea before sending your project to the CPU just to take a look and see what Dynamo tells you. I mean, Dynamo just makes an estimation that I take so much time for a Fourier transformation and rotation for so many particles, so many angles for one particle, just for the alignment process, it should take 40 seconds. In this case, there are only 8 particles, and actually the project is going to take so much more because as the data set is so small, we're going to invest a lot of time in overhead, just in creating the project and these 3 minutes that are always the same in this project or in a project with millions of particles. So that everything is okay, and we can go to the real world and start thinking about how we want to run our project. So So we go to the computing environment, and here is where we tell Dynamo what is the destination of the project. Destination means that sometimes we want a project that will run under MATLAB or under the standalone, or with a GPU in MATLAB or the standalone, because the fact that we are creating the project here as a standalone does not mean that we have to run it as a standalone. Normally, or in many cases, that's not even the case. A lot of times it makes sense to create your project locally in this machine when you have your screen and everything works kind of fast. And when your project is done, you put it in some other machine or in a cluster or in some other place where you don't have visualization interfaces, but you just want to crunch the numbers. In any case, now we are going to put it to run it here. So we are going to choose the standalone. If we use the GPU, we have to tell Dynamo how many GPUs we want to use, and we want to ask Dynamo if it finds the GPUs. Let's do it actually. Info of NVIDIA. Yeah. So Dynamo asked the NVIDIA driver which are the GPUs that we have here, so that we could even, it will work, no? Maybe we can, okay. We could even use these 4 GPUs to run the project. We are actually going to do it. Let's say that no running processes found. We could use all the GPUs that we see there. Let's just expand a little bit the field of view. And Dynamo is just waiting for us to tell which GPUs we want. So that let's put all of them. In identifiers, we put 0, 1, 2, 3. This motor, well, there are different algorithms. This SPP or CUDA, just put always SPP. This CUDA never give a real advantage, so that they use the standard one. And tools, we can take a look on how many cores. Well, we have 16 cores, which are actually too many because we only have 8 particles, so that we cannot. Here, if we are using the standalone, or if we are using the MATLAB with a parallel toolbox, we can tell Dynamo, okay, this is for the alignment part, and for the averaging part, I want to use 8 cores, for instance. Okay, so that they are different things. I mean, you don't. If you have the GPU is good for alignment, but for averaging is not so much, because the GPU, what the GPU likes, is to have one piece of data and do a lot of rotations on that. That is the definition of alignment. If you use the GPU just for rotation, that's you're losing a lot of time just transferring things into the GPU. So that here I will just put my 8 there, and that's it. We have created. Yeah, thank you. Short note. I mean, this MPI cluster, well, that's what you use when you're working with a cluster, and in this case, you have to bind some description of the header. You have to. There is some information about how you create this file. This is just a file that will help Dynamo to understand what is the syntax of the cluster in which the Dynamo job is going to be run. So that in this case we just ignore it, click on OK, and then we go for the real thing. We check the project, and apparently Dynamo is reasonably happy, no errors found in project. But we see that we still cannot run the project. We have to do a previous step before. We have to unfold it. Unfold it meaning that it creates an object in the disk that represents the project and that is ready to be run. we click on it and see what happens. Okay. It's apparently frozen.
Oh, okay. Yeah. We reconnected you and stuff.
Okay.
Decided to.
Perfect time. Please pick up it.
Don't worry, it's still there running.
Yeah.
It's just asleep. Oh, what? Did you turn off?
It's asking for money for free
Oh, you
trial.
turned off the unlock. Yeah. Of course they want money. Okay.
Okay.
Sorry. Right, now it's alive.
Okay, so now we unfold, it takes some, or it does it very quickly, and it creates this ptest.exe file. And we can just run it here, but actually what I normally do is I do not run it here in the window, because if I press on run here, this window, the Dynamo window, is going to be busy running the project. Actually, what you normally want to do is to create to use another shell in order to execute this this command. For instance, here. Okay. You see that we have the ptest.exe, and we can just ptest. It has in the standalone, you normally have a very big initialization overhead, because it will have it has to do two things. First of all, it has to open the MATLAB runtime, but it does it only once. And the other thing is it has to create an internal device for parallelization, so that we ask for 8 cores. So Dynamo is telling the internal local version of MATLAB that please, we need these 8 cores prepared. It normally takes something like 30 seconds, and then the pool is ready, and now it's actually creating the GPUs, the project. So that it first goes to iteration 1, and it informs you on what is happening at each moment. So that we have 4 GPUs and 8 particles, so that 2 particles are going to be hard assigned to each GPU. Are you running also the projects, because it means it may.
I did notice one little thing that happened once, where the first iteration when I run it, sometimes the GPUs take about a minute to decide to actually process the code. The code is sitting there on the NVIDIA SMI, but
Really?
It's just not doing anything.
Okay.
So you might just have to wait, or look at NVIDIA SMI.
Okay, let's check. Okay, apparently the GPUs need some warm up, but in any case you can check in progress. So it happens every time with these GPUs?
No, actually, it only happened one time.
Okay,
So
that's.
maybe now it's happened 2 times. Let's see.
Okay, well, in any case, this overhead is.
Hey, keep talking. I'm just gonna look.
This overhead is not so dramatic, because here we are just working with. Yeah, I think that.
Yeah, this is.
Yeah.
Perhaps a bug, but we'll get around it. It's okay.
Mm-hmm. Okay. Okay, let's see. Okay, yeah, apparently, you see what...
Something happens.
Oh yeah, I got to iteration 2.
Is somebody else running this project? Because we are all using the same user, and if... okay.
I'm running a different one with my name on it, and it's much faster. It's
Yeah,
finished.
And you're
But I
doing...
was using one GPU only, so I think it might be.
Yeah, okay. Then the problem is that we are interfering with each other, so that what we can do is... no, okay, don't worry. Okay, then...
Use
Actual-
the particle size and GPUs is actually spend more time than I/O.
It's usually done.
Okay, well, in any case, it's done. Iteration 3 is done. Progress. Well, apparently it was some kind of interfering, but at some point when the GPUs are actually unfolded, you see that it just did everything. You can even go to project and take a look on how long did it take for each tools.
Not that we're running that day anyway.
Check used execution time. Yeah, you see that apparently for the first iteration, it actually took 2 minutes, 14 seconds. I don't know what the GPUs were doing, but then it's more like that. It takes 9 seconds or 10 seconds or whatever. Okay, now, how do we... Well, I suggest that you just use the standalone, because with the GPUs you are going to interfere with each other.
I've actually been able in the past to run as many Dynamo processes on the same GPU at the same time without any issues. So I guess that's probably
Yeah, but you actually have a hidden issue there. I mean that imagine that I'm using 4 GPUs and Philip is using 1.
Yeah.
It means that for this one GPU we're having 50. We're having the time, but
Yeah.
Dynamo is going to wait until my GPU 0 is finished, so that you're wasting the time of the other 3 GPUs. So that it's better not to have. I mean, or if you have several users on the same GPU, they should have only one GPU. You shouldn't have several users sharing several GPUs, because that's bad. Okay, so that now we can view the results. Last computed average. So that's we can also take a look on the last computed table, so that we can take a look on the shifts and rotations and everything. But in any case, what happens here now?
push this little
Yeah.
Oh, you got it.
Yeah. There are different ways to interact with Dynamo. Once you have your results there, you can go to the show area and you can pick exactly what you want to see. For instance, if I want to check just the last iteration, or if I want to check even better than that, all the iterations, I would say from 0 to 3 here in iteration. And then what do I want to see? For instance, the average, and I choose one of the viewers. In this map view, we're going to see the different iterations at the same time, so that here what we are saying is how the iteration worked, how the iterative process worked from iteration 0, 1, 2, 3. What we see in one big slice are the same slice in iteration 0, 1, 2, 3, iteration 0, 1, 2, 3, etc., etc. Each one is a different height, so that we can actually check one of those heights. Let's take this one. I press on C. I mean, I can also move the height here, so can go to height 31, 30, whatever, or put 2 different heights. Well, here it looks like there is nothing, but it's only because this browser tells you the non-scaled intensity of whichever is inside, so that we can just normalize everything. And now we see that is the template that we entered, that is what we got in the first iteration for this slice. That is the next iteration and next iteration. You can play a little bit to see how they look like when you symmetrize them or reset them. Or you can just move them to Chimera, assuming that Chimera is installed. It's not installed. Okay. Okay, it's installed, but it doesn't want some OpenGL thing. So that. But well, Dynamo will try to pipeline with other software, so that if we want to see it again, invert or reset. That's let's see, where you get it. Another way of getting the results, what is the way that we normally use, is with the command ddb, so that if you know what you're looking for and you don't want to go through all these navigating windows, there is always in Dynamo some command in order to do the trick. For instance, what I'm going to do now is ddb, go to the database of project ptest, get the average of iteration 2 and visualize it with dview. And it's a question of deciding how you feel more comfortable with. I mean, if you don't like to memorize obscure commands, you can always find everything in the GUI. If you want to do things swiftly, it normally is a good time investigation to memorize, to go to the help of DDB and see how you can get templates, tables, averages, results, intermediate results. Everything is in the internal database of each project. So that that will be the detailed explanation on how this project, how projects work. Now the idea is that you take the PDF that Alex prepared and do it on yourself from the very beginning. Create a project from start and use that project to solve the test dataset, exactly as we did here.
So we have some actual real data that you can access on this machine that some of you are SSH'd into. So if you SSH into there, assuming that you all don't collide and clog up each other's connection, you'll find it. Let me open up a brand new terminal and go to the Tomo Workshop user. Of course, you'll just SSH in there. You'll see in the home directory that we have a folder called Dynamo Workshop, and here we have a subvolumes folder, and in here we have 3 different projects. There's some unnamed projects, one with small unnamed proteins, another one with membranes. This is a difficult project, so I only recommend this if you're fully comfortable with everything you've just seen and gone through. And the other one is a proteasome data set that was collected with phase plates. So I'd say the first project's the easiest, the small unnamed protein project is medium difficulty, and then the protein covered membrane project is higher difficulty, and there's a lot more particles in there. So go ahead and if you're going to work with these data sets, go ahead and make your own subdirectory in this directory right here, home tomography or Tomo Workshop, Dynamo Workshop, subvolumes directory, and just link from within Dynamo to those data folders and go ahead and work through the tutorial PDF using those data sets if you wish. And we'll walk around and help you out. Okay. Oh my. Space normal version and then add some 192.168.4.1. So you mentioned it's finished. Yeah, it's issues that constantly get off. That's what it's supposed to be. So you can just view whichever revision measures in the multiple revisions. Cool. So then from here, go on this. You can get next one sheet projections going average. Oh, I understand. Okay. I know. So this was this is an issue with this thing. So this weird annual constant takes up figure 1. So you have to change this up to figure 2. Yeah. So this is a little bug that we can fix. And then now you can do that change. You can. It's just that it's if you're using the Dynamo command console, that thing takes up figure number 1. So if you're ever trying to display something from the GUI and you're given the option to specify a figure number, change it to 2, 3, or whatever, and it will show up instead of not showing up.
Of course. And this is where I keep getting stinking out. So I'm trying to just create a header footer, and I want to make sure that the architecture is correct. Because like, I don't know what to have to wrap. So for instance, should I be from my folder? Yeah. I mean, so they're all my files, and that is concerned. I don't want to write to the wrong place.
So you are
And I have my folder, so should I be able to go in my folder?
No, I mean, we just doesn't create like to create. I mean, what it means that
I can do anything. I don't know
these
how to
files actually.
get you bootstrap here.
So it should
So did you?
Well, first of all, the file that is
I
here,
did, yeah.
it can always be saved, so that if you could save, first created is 10.yen. Exactly. And that if you want to show it with Chimera, you can just invert it.
Before we do that.
This is, I mean, this is your local version.
No, I'm still learning.
Okay.
Because I was halfway through, so I didn't want to go back.
Okay, yeah, I think it's better to
project or you might say project.
I'm going to try it again.
Additional specifications.
so it's going to
Or
I think there's we have a process on the side. So
put in two
don't
different
think
things.
it's this was
Okay.
Okay. So after this,
You know, this gets really well results. So, and then pretty much just the time.
looks good to me. So that
So what is the
what better to do is
That was all like what I just did. And this, and then what I just wrote in my file location.
okay.
To, so
Okay, because there is a
to location. Yes. Okay, so that's saved. And then, so here's.
TV.
Instructions. This is small, and just start the building project.
No, I just have
Okay.
this in the
Okay, I see.
And then you open up.
Okay, then it you can use 10 direct to it.
Just name it. It's not
Okay, no resource, you know.
I think
And what we did already.
And we did it already. So
Okay, so it's already there.
Yeah.
So we can just open it.
It
It was
will automatically.
Okay, it's done. So we open it. Okay, so we have our
The previous
So
version.
now it doesn't
Yeah.
work.
We have a list of commands and those numbers here, but we will do that in a moment. So the tutorial, we create a tutorial says and a project into
And there's the sort of
only allows that when there is informing us, that is
Got it.
creating
Yep.
everything.
Thank you.
And it has created the synthetic dataset plus the project itself. After we come here, we take a look on the projects. We see that it's already in this. So that what we have to do now is just to open it
Okay.
and prepare it for execution. That is what we call performing. So that load. No, we are doing everything in the hardware. I mean, normally what you do is everything with the command line is so much faster that we are giving our first steps. Check what numerical parameters. Can take a look on numerical parameters. This should be okay.
what I want to take a look is at the computing environment. For instance, I'm going to take a look at how many cores you have here. You have only 2 physical cores here. It's better than one physical core. So we try and take the standalone. We take 2 cores. We also take these 2 cores for the average instead. Okay. And we unfold the project. And now,
I was just pressing run.
oh no, you can press run. I mean, that's why the button is that. But the question is that if you press run, this window is going to be busy running the project, so that you cannot do anything else in the window. And normally, what you want to do is you have this window open, and you use a different terminal. Do I create a tab? So I will just execute it here. The thing is that this shell is new and it doesn't know anything about Dynamo, so that we have to activate Dynamo. And now it will work. So it takes a little bit in order to open this MCR, and then we'll take still another little bit in order to open the internal device for parallelization. But that's just overhead. But it's the same thing for each particles or the thousands. So it's just very inconvenient for demonstration purposes. Oh no, well, I mean, running will not be that complicated. It will be okay. So it opened the Urman's mapper, the MCR, and now it says, oh, but we need this multi-core system. Now it's using this parpool. This parpool is the MATLAB jargon tool for internal harnessing of the code. And at some point we will finish it, hopefully, and then we will inform about each one of the particles. Actually, the standalone with the standalone multi-core version is much more communicative than the GPU version, because in the GPU version at some point just control transfer to the GPU, but here is a previous pool of 2 workers was available. It was initialized one, so that it will remain open for all the sessions for this project, and it's already done with the first iteration. So it's well, exactly. So that now it's mainly overhead. But well, you can just check it here. As the project is computing here, it means that this window is free.
Check the everything, so should I? And then I think in the future, Alex will be giving you all the.
Just grab.
They're just gonna get will they have a set of clip rings and stuff? Is it? They will keep the
orders. Start installation.
Okay, so I'll grab them every time I click my shot. Okay.
You can add them arrow.
No, yeah.
Perfect.
So I'll be. How many? Should I just count how many bits I have in the past and then charge?
I don't know if it will work because of the following.
Okay, okay.
In order to work, it has to be installed and visible from the shell. But that means that when you open the shell, you have to bind idea to the shell, I mean this library path or whatever, before starting Dynamo. We can do it before, afterwards, but it would be a little bit more messy. I will show you. Well, it's done. Hopefully, progress, yeah, hopefully done. So blue plus computed average.
you know your first chromosome, your average. So,
That's beautiful.
so, yeah, that's the beautifulness of the beauty of synthetic data. So let's check if we can get the average. We can do it. I know that that's a little bit annoying to the command line. You were asking me before where those things are. You can always use, instead of using the B option, you use the D option, the display, and it will tell you where the file is.
Okay.
Exactly.
Okay.
Exactly. We tell Dynamo DB test date minus display. And then you can just transfer this file directly into Chimera. So you don't need to do it.
Right.
But well, let's try to see what happens. We will do it in Dynamo. DDB, test, A for average, and then we transfer it into map view. Yeah. Let's see now it best. Okay, no, it best. Apparently
So I
there's
was trying to tell you guys the clippings and about the difference. So I think I count probably about 50 then.
the location of command Chimera
Yeah,
is
So you better do it.
Yes.
From the past. It's
but
Then yes, if it's
assuming
50,
like-
then yes.
Assuming it's for every session, then something.
let's try to find
Yes.
it.
Then multiply by 2, just to
You can just, that's just basically a bag, you can just grab a bag,
Probably not.
So this is the shell of the
Okay,
know
guys,
what it
time
is?
to tell you guys.
and I think I just ran it from, I just downloaded it and then
Desktop? Okay. So that's the executable.
no, I think it's, I don't think I ran it, I did download.
We're not talking about that. Oh, that's much easier. Why is it expected? It should be able to. I will check it.
I don't know, I think I tried to figure it out.
Oh, that's that was the installer. I'm sorry. Something.
What's the set table? Okay, then what I will do is I will export it into the path. Export it. Path equal path.
No, well, actually, they were extracted from the documents from yesterday's tests. Projects.
So know the path and the shell knows where the nearby is, right? So that if we start Dynamo from here.
So Bill, in this folder on this other computer,
Oh, okay.
you'll find these 3 data sets right here. And so you can work on those as you wish. Cool.
Still recording.
You know, it's a question of putting this into the buzzers. Those buzzers is always go and you know what is that.
I'm not sure because I'm just on SSL.
Yeah.
So because I'm on the standard one, then it doesn't show. No surprise. No. Yeah, so then you go to
No.
Yeah, now I go to Dynamo.
He is lucky.
Okay, next second.
So where's the name? That looks frightening. No enterprise.
From my last time. Yeah.
What was causing it?
So how did that just?
Yeah, the first graphical operation in session.
Some of the directories are like I think it's
Okay.
just SCP stuff.
You can see what
Yeah, you can do that.
Yeah.
You can put it in the Dropbox and
Well,
no. The shell knew
Yeah,
what the
I
new
know.
so it can transfer from
Yeah.
other people. You were the shell.
I don't
Yeah.
have
The proteasome should be fine.
the proteasome. Yeah, I can do that. Somewhere. Cool.
Yeah. Oh, wow.
There you go.
Great, thank you so much.
So I think it is alright.
It looks not very convinced.
Yeah, so when I don't know what I'm doing, I usually struggle.
Okay. Can we help somehow? Or it's
Probably,
a, or it's a desperate situation?
No, I think
Oh,
we
okay.
can.
Okay. Oh, but you're really.
So,
Nice. Where did you get all these? Those are from the from Alex.
yeah, it's actually fine data also, but
And you have,
I should learn how to process it.
okay, and you have transferred it locally.
Yeah, like a hard
in just a second.
So, no, I'm sorry, I'm running on
That's a
Castano.
question. Well,
I'm running on that, yeah.
Okay, okay.
So, he helped me donate a hard link to that. So then I'm gonna open this and CCM.
No, DCP.
DCP. And then project.
Oh, yeah. That's why it doesn't work.
It just tells me that it found the minutes.
So,
Yeah. So Dynamo
Good, good.
somehow changes the,
and data is now parsed,
shell
just
script
locate.
or whatever such that parsing and SCP don't work
And then
from
table.
that machine. This has been true for ever since Dynamo's been
I
out.
don't have it.
Right.
I've never complained about it.
So I just want to create a
Stop
link.
So what I usually do is,
And
and I'm going to do it really temporarily here.
Oh, well, I mean,
Move
you should give Dynamo the credit that
Dash
you
receive
receive. But it has created a table for the data
somewhere
so
else.
that you can check it. But the idea is that
And go back,
when you
start the
create a
copy.
blank table or a random table, it has been created for the data that was already there.
the
I mean, it's good that you check. I mean, it's, but that's what one would
Yeah,
expect. The table is as big.
Oh yeah, you
as
just
the
did it while I
as
moved
the-
it.
And then when I
Which one are you
check
publishing? 'Cause
this,
some of
Mhm.
you're an
Good.
intern.
so this was
Don't publish.
concerning. I don't
The
know if
data.
that's something I have to specify.
No, you don't. I mean, that's.
It's good.
If you want, you can put the updates and the focus, but it's not necessary.
Okay. So then we'll
I
just.
mean, as a token of reference for the future, normally when you do a check thing, if you get warnings, it's still okay. If you get red, then it's the moment that something is but it will tell you exactly what is the error.
Okay.
So that these kind of things, it will just generate a warning. And this in particular will not even generate a warning here. It just means that, okay, this table does not have any apics and not the focus, but this branch of execution, I mean this algorithm here, does not use it. So that,
Okay. So then next is template.
yeah, you have a really
So,
one.
oh, that's, I was trying to create a template.
But you have already one there.
You put the template in there, yeah, the computer that way.
Maybe you did it. I mean,
I don't know what it
I mean,
is.
if you created this average, you click on
Oh, I
average
did
data,
that, yeah.
then it created that. I mean, you can
Yeah.
click on it to see how it looks like, and double click, and then view.
So then nothing comes up.
You have to change the figure.
Oh, you have to check. Oh my god.
So I started over because that's okay.
I would try and make sure that I'm right about that. So I'm sure.
I'm not sure. I'm not sure if Dynamo map you. So because you are in the, so you are, yeah. I mean, no, I think the X4 were getting to max. It's simply not working for the standalone.
I do see different issues with the source. You mean from the other computer?
Yeah.
I have seen that. But I've also seen it work on some people's files.
You have also seen what?
I've seen it work on other people's files.
Yeah, I think what you should do is you could run it locally. Or what you can do is you can create the project locally and then transfer it to the cluster and run the transfer project.
Even if I don't have the stuff stored locally.
What I would do is what I always do is I have one copy of the data locally, another in the cluster, and then I use this bit here. That looks a little bit unknown. No, sorry, I don't want to check your email. Can you give me a browser?
So, what files would you be sort of start? I mean, so essentially what we done on the Twitter, right?
What is the
I mean, that's why the extensions on file, right?
We'll start
the
with yeah, so these are all just beginning models. Actually, the directories
I think
are,
we'll go to our.
for example, small directories.
Yeah, okay, then we just do it locally then.
So this is the data that
So
you
that's
line.
Yeah, that's how I was doing it before.
this is
When I went to
the old flow of
university,
for
so
the
I
reasons
don't
I
know
have
how to
normally.
do
But you use to create your
We just
project
ran it
locally,
anyway,
you div it out my project, so that it creates a compact version of the project. You transfer it to another machine and carry it to the other machine.
So in this case, I
Yeah, this is
would
my down.
So it completely depends on
that because in the
if you have
cluster,
single
it's not
particles.
stored.
Okay, in the cluster, we can still work in the cluster. The only thing is that apparently we are not going to be able to see a lot of things because
But can I do this in reverse, where you tar the project on the cluster, send it to me here, and then hack it on my computer? And tarring it will just make it faster sending it, yeah?
No, I mean, targeting is more important than that, because imagine that this is your project, and this is your folder. You're here. You created a project here, and the project is linking some file that is in the same folder or in another folder or another folder. So when you tar from this folder, maybe you're not taking all the files that are linked to the project. So when you tar a project, you make certain that what Dynamo does is it looks for files that are in other locations of the file system. It puts them in the project and indirects the project itself to look inside the project itself for template, mask, whatever.
Which ordinarily I think with my own settings would be okay. I don't know in this scenario if that's possible, because I don't know if there's a permission there.
It shouldn't be any permission thing, and if there is, normally you can cheat it.
I don't feel those individual slices, right? I sort of.
So should I try it or not?
Okay, what they will do now is
Right, that's what I
major
mean.
reconstruction.
Alright, so this is optimally
try to see if there is a way so that we can create figures.
Tilt series with a tomogram. That's
So what do we
I open another terminal with just a Dynamo instead of Dynamo.
Is it
Yeah,
like a landing
that's-
page
Is that
or
okay?
single
I
product?
think so.
no, it's potentially a lot more complicated.
Yeah, okay.
So
Windows,
yesterday I gave the first show about that.
Yeah,
That's okay, it's okay.
So,
There'll be a video.
what you can do is
I think you come out next week or something.
is open on the terminal just with Dynamo and use the view and then, sorry if I did.
No, So if it's
Oh, perfect,
this one,
perfect.
that I already have open.
So that, let's see, let's
So
see.
before we do this, we go to this potentially to copy paste procedure.
I know, but this is a local, this is local, it's,
And then once we have that, so we have already
Okay.
done the line.
These are from tomograms, from tilt series that align. Yeah. So this is down the line, a few steps.
Alright, cool. Yeah, that's what I was just.
Like disconnector, there you
Yeah,
go.
I guess we like this.
That's okay, it's okay.
There's a one in the dog. There was a one that we could show aligning it, so it's just like you just sort of you can align frames and it's not really good.
No, that's like the global perspective on the entire tilt series tomography problem, and Dynamo is working on the end, the last few steps there.
It is another program to do that.
Yeah. Although he is
try to.
doing those steps. Yeah. So maybe in the
Because
future,
I just
maybe
have to
in a year,
connect
those-
No, yeah, maybe they got
and like for what.
Exactly.
Yeah, I could work on it.
Why not next week?
But it's
Yeah.
exactly the same. No, I think
Cool. Alright, so.
there's a problem
Awesome, thank you
when
so
you
much.
pitch forwarding from the.
That's my head.
It's not that it's not
Maybe
processing.
I should get
It's not that it's not processing, it's
No, no,
only
it's-
that I
Are you
can't.
looking
I'm certain that it's processing everything
Okay.
because otherwise we would see a lot of red things here. It's only that we cannot see it using a Mac connected to this workstation for some reason that I cannot even start to review.
Yeah, Julia.
So that what they will do is
she has like 3D
the following. We are going to work in your computer.
Really hope we can find
Oh, that's cool. She was at the curiosity after.
And we will just create everything here. And we will do the we will run it in the cluster because that's actually the way that people normally
Nice.
work.
Yeah, we're really
How many
excited.
people normally work.
Oh,
I
so
don't
the
know.
files don't even have to be,
Crazy.
the files don't have to be locally to do that, or
I mean,
do
it's
they
so
do?
interesting.
It's convenient to have the files locally, but yeah, let's import the files.
Yeah, so that's where you're at. Cool.
Yeah,
That's
so,
good.
I mean, I feel it's a good thing for me. Just start learning this.
Yeah.
And look at the
And
proteins of
we should just cp
from.
Oh, that makes sense.
what?
That makes sense, I thought it was going to be more
Trying to actually do these construction.
No, it shouldn't be complicated at all, and that's easy.
Factors, so, yeah, I think
Okay, that's it.
complicated project, I'm sure.
Hopefully you got few examples.
Yeah, sample prep is, of course.
Total workshop, 192, 168,
Trying to work out how to
So much is lower than
or come up with around
Oh wait, no, that one.
waiting really long, a month or more, and then just getting
192, 168, 104.
and then doing grid screening. I'm always very stressed out about my samples.
Yeah, making your grades must
Yeah.
be super stressful.
It's always stressful. The day before the prayers, so you just screen them if they look good. And I'm still really freaked out. But then screen them and say, anything can happen. They just stay there. Yeah, so
Is all lowercase n, y, s, b, c.
Figure out how to express something.
Thank you.
yeah, or just get another sheet forward to us. Cool. Awesome. Thank you so much. We're just gonna put this down.
Well, I
That's
thought I did the proteasome.
Okay.
So I created the project correctly.
Yeah.
And then I was going to load the particles in, right?
Absolutely.
Now, did the particles get loaded underneath here? Is that how that works, or does it, where does it create another copy of them, or does it?
Nope,
No,
it just
okay.
points directly to them. So
Oh,
all you
okay.
need to do, is exactly what you just did right there, and then just hit OK. That should work.
Okay, but
Okay, didn't think it worked.
I'm pretty sure that it wouldn't let you go any further if it didn't work.
Okay. Okay, good.
So that's a good sign.
So I inputted the particles in
Yeah.
the table.
That's
Yeah.
shows. I mean,
Okay, so now I start getting.
Getting
Awesome.
Okay.
Do I have a table? Is there a table already in that stuff?
There is a table sitting in that data folder. So
Oh.
let's look at it. I'm not sure. It's called crop.tbl. So can you do a more on it?
Who created that TBL? Is that
That was automatically created when the particles were extracted from the
So
tomograph.
apparently you cannot.
By what
see
program?
into this.
Dynamo.
I'm thinking that they maybe set up permissions things and input the data. You can't SCP anything.
No. You can.
Oh no, it's
You
know what?
can.
But Ash knows.
Did you already change it back?
Yeah, of course.
Oh.
Okay, but now
Here's
going
clock.
in the other direction, we can SCP to us.
You can, but all you need to do is it gives some type of Dynamo MCR error. Is that right? No? It does it give a Dynamo MCR error?
Yeah.
Yeah.
Yep. So what I've found in all my Dynamo career, I've never reported this, is that if you put the source Dynamo Linux activate MCR script in your bash RC, and then if it's sitting in your bash RC and you try to SCP from another computer and pull data, Dynamo doesn't allow it's SCP or rsync start by running the bash RC.
What?
They do. And so Dynamo somehow, for some reason, stops rsync and SCP. It just
So you mean
kills
the fact
it.
that the bash RC includes Dynamo is stopping SCP?
Go ahead on that machine and move bash RC to bash RC back and try the SCP.
Wow,
And it
that's,
works. Yeah.
that's
I don't
crazy.
think I've ever reported that. I just thought
I don't know.
maybe this was
I mean, even if you
I don't
report
know.
it, I have no idea what you can do about it.
nobody else reports.
How do I inspect the table? Is there a right click on
Oh,
something?
yeah. So
Okay, so it loaded.
yeah. Oh, you actually looked at it over here, so that's
Yeah.
equivalent to an inspection. But you can click on there.
Right click or just
Slide the regular, and then right click on the table location.
up here?
And then you can view it in multiple different ways. So
Oh, I see.
the top like 5 or 6. If you have this you remember from the
Right.
workshop. So yeah, just basically play around in Dynamo with. There's so much functionality, so I recommend for learning purposes do everything.
Do I have
And then move the bash RC back. But yeah, there you go. That's the only thing in the bash RC you can check. There's nothing else.
Wow. No, how did you figure that out?
I just tried things until it worked, I think.
How did it know it was there? So, that template.
Sorry?
How did it realize that one of these files was a template?
Sorry, that
It
Dynamo is
auto
not toxic.
search for that file name.
Sub-average.
Okay,
Yeah. So that was a default file creation during particle
So
extraction.
do I do one of these things?
No, not here.
If you want to, it's completely up to you. Maybe look at your sublimate average to see if it looks something like a proteasome. Right click any text location. Right. And then just view it and see if it looks alright. If not, then maybe you want to make your own. Right. We have this one. You do have this one. Okay, close this
So
one.
I need to create a new one. So particles, folders, this one, table.
I made it. I could make it even smaller. This thing.
Huh?
I could make the resolution even higher on the screen.
No, that's not the issue.
Oh.
The issue is that you open this up
Yeah,
from
do you
the
have some
Dynamo
kind of,
X console. Is that right?
Initial orientation.
That's the issue.
Which
So
are those particles?
go
Are
ahead
isolated?
and go here, hit OK,
So
close out your
there-
project and all of your Dynamo windows, and then let's
We've
reopen
already
Dynamo
used everything
without the
outside.
X.
No,
and
no,
just
no,
the
no,
regular
no, what I
Dynamo
mean is that
Why do I have to?
there are
because
different
when
strategies that
what
are
we
on,
what I me
what
and
is
Daniel
what you
just
can
learned
do.
during
For
this
instance,
workshop
if
is
you
on
are
Max
trying to
when
work with particles that come from
uh,
underground,
no, not
then
on
you
Max, but
probably
with
want
this
to
new
use some
Dynamo
kind of
console,
prior information because the
which
fact that they come
hasn't
from
been fully
underground
tested.
is very
It
useful.
takes up
If these
the
particles are
working. So this is all
isolated
written
and they
on
can be
Uh-huh.
any random
MATLAB.
Quite literally
When it
the
makes
same
figures,
grids
it
that affected
numbers the
single
figures,
particles.
starting with 1.
Okay,
The
then yes,
Dynamo
okay,
console
data
window,
is with a
where you
random
can type
table,
in Dynamo
with a random
contains,
feature,
takes up
just can
figure
particle,
slot 1. So everything in Dynamo, when you try to plot a figure,
no.
it tries to plot it to figure 1. That figure 1 is the Dynamo console. The Dynamo console
Okay,
says no.
there is a
not to do
small
that.
thing
I'm
that
the Dynamo
they
console.
have
I
to
can't do
make
that.
aware
And
of.
so therefore,
They have
nothing
to
is
change the
plotted.
visualization
So that's
because
why we weren't
what
able
we
to
see
see
here is the
it.
pure
And so that's why I'm
visualization,
asking you to
meaning
close
that,
stuff and then open it up without the X. So yeah, just it saves everything, so it's okay. It's a smart piece of software. So I guess tomorrow I'm not using the Dynamo console.
if you are taking,
I mean, for the CentOS, in the boot up menu, doesn't really read that, because you're trying to convert it to Ubuntu.
Wait, it doesn't read what?
The boot up stick, so you install it by the USB stick, right?
You are,
No, I installed it.
meaning that
That's all by CD.
Exactly.
By
So
CD,
if,
yeah.
I have a CD if you want.
Ubuntu?
Oh no, I'm sorry, CentOS. Sorry.
Actually, everything is fine. It's
do you
only
need
use,
a- Wait, is it better by
use, horrible because it is
From the
I've
is
heard
there,
it.
but
The USB doesn't
From
really
the
see.
It doesn't work for the USB.
It doesn't seem to sense it.
so we can just use it.
Okay, then yeah, I recommend burning a DVD or CD.
That usually works better.
Well, it will always work because it's the oldest
that,
technology.
if we
you know.
cannot,
Before that was floppy disks.
Find a contrast that is good.
I don't think I have
Much,
enough
very wrong, I really need
Do you have CDRs
I mean,
that you
if
can
you
burn
are,
or DVDs?
I mean, if you just
Yeah,
have random
when you go
nodes
down
that,
the stairs
average into
to the
particles,
F20.
I think there's one stack over here.
Ah, great,
particles
perfect.
are
Okay.
there.
I know
Or
which
it
one it
means
is.
that you're going
But
from
yeah,
different-
that's
I'll try to get
for
that.
instance,
that's what I
that means
recommend.
that,
But
if
Okay.
you are just
sorry, it'll take time.
doing this,
What,
this tiling,
It says, I don't see anything.
the
in my
particles are
directory.
not centered just because they shouldn't be centered.
Then of course it's going to be
I don't see
extra.
anything in this
But,
directory.
but that's what you
Yeah, it's all
you
in
are
that
shooting at
virtual
the very
project
beginning.
Oh, really?
in the settings.
But
Mhm.
let's start masks.
Correct.
I
So
will
you've closed all your
use
Dynamo
before
windows, is
masks.
that right?
Because there is one
Oh, you have one over there.
philosophical question about
Where it went.
about what how to use the projects in Dynamo. What I mean is that
Cool. Well, I think it's
many people have the
Oh, well,
intuitive wish of
because maybe it'll
creating a
make it
project
work or
that
anything.
will extract all the information
Can you
from
do
the
it
very
LS?
beginning, so that they say, I want to create this mask.
Okay.
Uh,
go up one.
normally that's what they do in a
Go
second
up,
step.
yeah.
What I always
Now do your Dynamo
is,
without an X and hit
I
enter.
create a project that
And it will
is,
give you
kind
the
of basics, and
command
kind of with a lot
window
of,
or command line
talent or
instead of the
creativity
Dynamo
doing,
command console.
and see
Type
how
DCP.
far it goes. And then
Yeah.
the situation that you get will
Yeah.
normally
Yeah.
tell you what is
Sorry.
the next step, how to create a mask.
No worries.
Because
Go to load and then projects from this directory.
Did I make it better
Oh,
or
oh,
worse?
are we gonna do it?
At least do
Well, no.
something.
Exactly.
Okay.
Exactly. Because
Max.
now creating a mask that is too tight or too,
Back over here.
as we don't know
Sure,
what
well,
they're
it's
going to find out,
Not responding
we
LS.
shouldn't care. We put a big
Copy
mask that
that
is not
name
going to
right
give
there,
us the
feels
best
pretty as
possible
a project.
resolution, but that's not why.
And then go back over
why
here.
this project
Just
is
middle
for.
click right there.
So we call it first. We're going to have a
Yeah,
second.
middle click, full paste.
So that
You have to go back
mask
here and highlight it
there,
again.
so that we
And then middle
embed
click
it into
again.
the project. Numerical parameters.
Oh, huh, that's interesting. Well, you have to copy that somehow. I don't know how Max
So that,
want to copy stuff.
This should be changed.
Control C usually.
Thanks,
I
Carl.
see.